Cool. Well, I really appreciate the invitation, guys. It's really great to be here. I Just a bit of backstory. I have been in the DevOps and containers and digital transformation scene for a for a long time at this point. I actually got started with the idea for Harpoon because we were building out bootstrapped Kubernetes clusters for U.S. Navy ships. So we were deploying Kubernetes from cloud environments to Navy destroyers because we're looking for standardized ways to deploy software. And ultimately, we ran into all types of problems with maintenance of the scripts and finding the right people with the right qualifications, especially for these sort of niche environments. And I started to think about what would be an easier way to solve this type of problem, and really put the power back in the hands of the developers, by not having to know all the niche aspects of containers and Kubernetes and the complexity involved. So I started thinking about ways to commoditize Kubernetes and DevOps at large, and that's kind of where Harpoon came from. So here we are 6 years later, and we have a tool and over 20,000 users, and it's been a ride for sure, and still a long ways to go. But I'll give you a little bit of a demo here just to give you an idea of how the tool works. When you first sign up, you'll get to this home screen. There's a project screen here. Projects, if you're familiar with Kubernetes, it's actually namespaces. So we divide up clusters by different namespaces, and you can create as many as you want. And it'll be the same cluster physically, but they'll be logically isolated units within your cluster. So when you click on one of your namespaces or projects, it takes you to the workspace screen. The first time you join or sign up, it won't be this happy glowing blue color. It will just be like a normal black or white box. And so what you do is you go in and link one of your cloud service provider accounts. So you could link AWS, which is what we have linked here, or Google Cloud or Azure. And once you link your account, you can go back to the screen and click what's going to be a start button. So the start button is actually going to do all of the underlying virtual infrastructure as infrastructure as code in your particular account. So we don't have it's not a fully managed SaaS solution. It's sort of like a hybrid SaaS solution because we actually deploy the cluster in your account and you have full control over it. You can monitor billing or attach, other cloud infrastructure, whatever makes the most sense for you. But whenever your virtual infrastructure is fully stood up, all of your load balancers and virtual machines and your actual Kubernetes cluster and so on and so forth, it'll turn this happy blue color, and then your cluster is ready to get rolling. So over to the left-hand side here, we have this concept of software. So if you're going to try to deploy software inside of your Harpoon cluster, your Kubernetes cluster, you're probably going to get over from here. On the right-hand side, these components are really more oriented towards Kubernetes. So these are, Kubernetes objects that you might find in any regular Kubernetes cluster, but they're more drag and drop. So if I wanted to start deploying some software, I can just search for things like if I want to look in Docker Hub for a database like MongoDB, I can just type it and I can drag it out and I can click deploy. And something that's a little bit different between Harpoon and some of the other tools that have come on the market, Harpoon doesn't have a curated list of things that you can deploy. It's dynamic. So Harpoon's dynamically generating all the YAML and all the scripts and things necessary in order to deploy and maintain your software in Kubernetes. So now we have this Mongo pod running. we can check the logs just to make sure everything's good. This looks like a bunch of Mongo logs. You can, on the pod itself, there's some controls, right? You can look at logs. You can open internal ports. So with something like a database like this, we may not want to open it out to the public internet because we have all of our sensitive data in it, but we can open an internal port. For example, Mongo would be 27017. And it's a service mesh underneath. So it'll dynamically create the routes and the services and all of the things necessary for other pods to communicate with our Mongo pod. Now we can also add commands, and you can even see and edit the dynamic YAML that we generate for you, in case you're wondering if you want to do any niche things or what have you. And then you can also get your pod information. So if you have any sort of services running, which we do now because I created one with my internal port, or I need my IP, then we can grab them all from here. And you can do this really with any software. So deploy some Nginx. And this is kind of like a fun little example, but ultimately people want to deploy their custom software. So we did an integration with Git repositories. In this case, GitHub. We can search for actual Git repositories. You can drag those out. You can choose the individual branch in our repository. We can use the individual commit for different branches, and we can build them directly here in Harpoon. What Harpoon's doing is looking for container build files. So as long as you have those in the top level of your repository, then Harpoon will find them and build your container images for you. Over time, we're going to move that further and further to the left and create more automations and ease in using the platform. So we'll be able to dynamically detect what tech stack you have and the best way to build, your container images for you without having any Docker files or things like that. So now that it's built, I can just click deploy, and I can deploy my custom GitHub software just like any other container image. If we want to increase the load of anything, we want multiple databases because, databases, you don't want that to go down. We can increase the replica set just by clicking a plus button or a minus button. We can reduce it. And so now we have, like a little application running. We have our reverse proxy. We have a database. But obviously if we were being paid to stand up a Kubernetes cluster, we'd probably be fired. If this is where we stop, we need some Kubernetes type things to make this thing real, right? So if the database goes down, we would lose all of our data. So Kubernetes has persistent volume claims or volumes that we can attach. And we just type in whatever directory we want to back up, and this will dynamically go out and generate EBS volume in AWS, since that's what we're connected to. And now we have our data backed up. Perhaps we need to inject some environment variables into some of our software, backend software, so we can type in key value pairs directly in Harpoon or secrets, and just click save, and it will dynamically inject the environment variables for those things into the pod. And then if we, if there's any problems, they'll also change colors in real time. So it gives you a status indication of if anything's off. And then ultimately, if we want to connect to our pods via services, then we can just attach ingress routes. So when I attach this, it's going to want to know what port I want to open it out on. Our software runs on port 80. So I'll just click that. And this not only creates the service in Kubernetes and the ingress, it also creates all the load balancers and the DNS and everything else we need to be successful. DNS always takes a little bit of time, so this will be a minute. But there's really no limit to the different things you can do in Harpoon. Everything's entirely dynamic. Like I said, secrets are over here on the right-hand side as well. And if you want to scale up your cluster, and you have extra nodes in your account, you can just pull this out as well, and it will automatically drop a new node that looks like this on your workspace, and then it will dynamically stretch out your Kubernetes cluster onto the new node. And you can do the same thing just by deleting one of the nodes to go back to a smaller cluster. And so I saw there was something related to data science. So should do like a data science notebook for Jupyter Hub. Deploy that too. Cool. Add another ingress route over here. This one runs on 8888. So this ingress route is finally done for our custom software. It is not a fancy application, but if we click in this little open an external window on the ingress route, it'll actually take us to the DNS or the load balancer of the application. And we can basically stick a CNAME or whatever in front of that and attach our domain to it if we want to. And then let's see. Oop. So better share my screen. So while we're waiting for this Jupyter Notebooks one, there's a lot of different types of software we can add. We can add container images from Docker Hub, repositories from GitHub. We can hook in private container registries. And Harpoon also has the ability to hook into any CI/CD pipeline. So if you go to your account, you can generate API tokens. When you have the token, you can just click this push steps, and it will actually give you all of the dynamic steps with all of your information. Obviously, you can't see my API token because it's a secret, but you can just plug this into your CI/CD pipeline, and then you drag out your software from what's been pushed from your CI/CD pipeline, and you can click just one button, and anytime you merge to master, Harpoon will automatically recognize that you have a new container image and dynamically redeploy your software for you. And you can sit here and watch it if you want to. Do a redeployment, or you can just, go make coffee or whatever else you need to do. So it looks like our Jupyter Notebook ingress is done. I'm actually going to grab the logs out of here because the way they created this, the tokens spits out over here. So we open this in a new tab, and we can see Jupyter Notebooks is running. We just need to paste in our token. And we're off to the races. Now we have Jupyter Notebook. We can data science ourselves into oblivion. So let's see. But that's pretty much it. We tried to make it incredibly easy for anyone to use Kubernetes and succeed at deploying their software. And we're not stopping here. Like over time, it's going to get even easier and hopefully be fun. Any questions? If you guys are talking, I can't hear you.
Okay, so Dominic, there is a question called as like, if we want to access the container and see what is happening inside it, how it is going to happen? Like, what's the process?
Yeah, I mean, all of these, hold on, let me just share my screen again. So all of these pods are containers for the most part, right? So you can just click on the logs button and we can see exactly what's going on inside the container. So these are the real logs from the container images that are running in the cluster. So if there's ever an error or a problem, you just open up these logs for different things and find out what's going on.
Okay, so do we have anyone? Okay, there is another question.
Hi, Dominic. Hi, Dominic. Thanks for the great talk. The low code drag and drop looks really, really cool. One thing which I wanted to understand is that the backend infrastructure, can we hook it up to, let's say, Azure or a private cloud, AWS, GCP, or not? Like, and how do we do that and make sure that auto scaling and other things are working correctly?
Can you
So
repeat?
Dominic,
Yeah, go ahead.
so are you able to hear the voice?
It was a little bit hard to hear because there's a little echoey in the background, but maybe you can just repeat the part of the question.
Yeah, sure. So the question is, especially on the integration with, say, AWS, if you really want to have integration with the AWS or Azure, how it is it possible to do that?
Yeah. So you can link whatever account you want. My AWS account is linked, but I can also link my Azure account by just clicking, putting in this information. I can link in my GCP account. There's a little bit different ways that all the different cloud service providers have credentials. So, Harpoon supports that. But you can actually link all of your cloud service provider accounts at once. And I can even tear down this cluster in AWS by clicking stop. And I can change my settings to Azure. And I can choose the different Kubernetes distribution I want. I can choose which region I want to deploy it in. And I could come back here after my cluster is done tearing down and I could click start and I could deploy this entire same configuration on Azure or GCP without any changes.
Thank you.
Yeah.
Yeah, thanks, Dominic. Is there any further question? Yeah, there is one more question. It's not audible. Yep.
So I want to know about the node recovery and pod recovery capabilities of Pod.
Node recovery and pod recovery.
Let's say if the pod goes down, how do we know if there's something wrong?
Okay, so the Dominic, the question is, especially on the pod recovery or node recovery, if node goes down, how the system is going to react?
Yeah, it's all part of auto scaling group. So if a node does go down, which we live in reality, so things happen, right? Harpoon will actually try to heal the cluster by itself. So if a pod goes down, it will immediately start spooling up a new node to take place of that. Obviously, if you have a one node cluster, in those instances, your software would stop working just like in a regular Kubernetes cluster because there's no failover. But this is one of the great things about Kubernetes. It's really great at keeping software running in a distributed fashion, right? So as long as you have enough nodes, your software will just automatically be balanced to the remaining nodes and your software will keep running and Harpoon will spin up a new node in the background and then it will spread back out over the nodes just like it would in a normal Kubernetes cluster.
I hope that answers the question. Yeah. Any final question? Yeah. Yeah.
Hi, Dominic. What are the packages the services that you install, right? And whatever you have shown in the demo. So does they support any type of thing or is there a separate packaging that we need to do so that those can be deployed? That is first. And the second one is how do we change these the parameters for these workloads to get installed because now the data they install for each client will be different. So how do we change those things?
Okay. So you mean, can you repeat the first question which you have? Maybe one minute.
So we use Helm as a package manager for installing it. So is that supported or is it something different? We need to package so that it automatically installs?
Okay, Dominic, the question is like, is there just, especially the how we install this particular one way is through the extension, but is there any Helm chart or something which is available where people can go ahead and try it out?
So Harpoon is a SaaS product that's available online. So if you go to harpoon.io, you can create a free account. The accounts are free forever. You can start up a one node cluster in whatever cloud service provider you want and use it for whatever you want to. So there's no real setup. You just register and you have an account and you can start using it right away. As far as like Helm chart support inside the tool, we don't have Helm chart support yet, but it's on our near-term roadmap. So soon you'll be able to search for Helm charts as well and pull them out, and we'll dynamically visualize them for you and make it easy to deploy them.
Okay. And there is other ways, a Docker extension. So you also have a Docker extension where you can just go ahead and install it with just a single click. And you had a second question also, right? Okay. So that second question is, if we want to say, do some kind of a configuration changes in the Harpoon, how does it look like?
For like configuring the pod?
Yep. Configuring the whole installation and the configuration part.
Yeah, so if you want to add environment variables or configuration to an individual pod, you can either drag out a config map from over here, or you can add a secret if it's something that you don't want other people to know. And then you just attach it to whatever pod you want to. And it pops up this menu with key value pairs. We can add as many environment variables as we want. We can choose environment variables. We can choose files inside the container. And then basically it will inject those environment variables into the pod and redeploy the pod so that now the environment variables are found.
Okay. Thank you. Thank you, Dominic. Any other question? Okay. I think we are done with the questions. Thanks, Dominic, for, I know it's quite late for you.
Yeah.
But anyway, thanks a lot. And I have been, interacted with you during our extension. Maybe in my slides, I'm going to show them, especially on the blog post, which we have collaborated with each other. But thanks a lot. And definitely have a great rest of the evening. Thank you.
Yeah, thanks so much, Ajeet. I really appreciate the invitation and the opportunity to share the tool with everybody. It's been a great partnership with Docker and building out the Docker extension. And hopefully everybody will go check it out. Thanks so much for your time, guys.
Thank you. Is it good? I think it is. Or I can use this one. Again, hang on till the time we fix this. Shall we get started? There is some echo. Okay, so I will get started with it. There is an echo which is coming. No, there is an echo. Okay, so right now I'm working as developer advocate at Docker. I'm also author. Echo? It is. Okay, how about now? Oh, it is coming in. I think it is nearby. That is the reason. That could be the reason. We are using two different systems. Yes. Can you hear it now? Yeah. Hello. 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 Huh? Is it better? Okay. Now I put this laptop that side better. Yeah. You can put this laptop that side. Maybe that could be the reason. Okay, so right now I'm working as developer advocate at Docker. I'm also, it has been like last year I joined in the month of April. I joined Docker, and then still voice is coming in. Or shall we do one thing? Hello. Now it is okay? Okay, fine. So I'm working as a developer advocate at Docker. Hang on. And then I'm also author at collabnix.com. Collabnix is a kind of a community site where people can come, they can contribute their blogs. They can even write about IoT, Kubernetes, Docker. So right now it has around 470 plus blogs. I'm also a former Docker captain. So being a Docker employee, I can't be a Docker captain. So I left captaincy like last year in the month of April. I have been captain since 2016, and the whole idea of captains are more like a contributor, like how you contribute code, how you contribute blogs, and speaking at the meetups, conferences. I'm also a Docker community leader. Community leaders are responsible for conducting an events. So we have been organizing the events ever since 2017-18. I'm also part of ARM ambassador. So ARM ambassadors are those folks which works very closely with the ARM community. So I do a lot of stuff around IoT, Jetson Nano, Raspberry Pi, and write blogs on top of it. In the past, I worked for Dell EMC for almost around 8.5 years, VMware for 1.5, Redis and CGI. Okay, so let me directly jump into my talk. So usually if you talk about Docker, right, most of the tools which has been introduced, it circles around the Docker, especially the developer workflow. Now, if you look at the typical software development lifecycle, it all starts with, you have two different loops. One is inner loop and the outer loop. Inner loop is the activity which developer does. He basically installs some kind of a software or developing tool on their laptop and try to install it, try to build their code, right? And that is a kind of a very frequent activity which you do, right? As a developer, you start building some kind of an application, and then you build it, you try to test it locally, and once it is tested, so what you do, you basically push it to some kind of a CI/CD platform. That's where your outer loop come into the picture. Now, Docker has been focusing majorly on the inner loop side of it, but we do also support the outer loop, because today, if you see, we have a GitHub action which you can use to either build those Docker images, right? So Docker has been providing most of the tools which basically caters to the inner loop. Okay, and today we are going to look into and deep dive into it. Now, it has been 10 years, and Docker has been there. There are so many tools which have been introduced both in the open source as well as the commercial. But at the same time, if you try to bucketize Docker, there are three different spaces. One is speed, security, and choice. Okay. Now, in terms of speed, there are a lot of new tools which have been introduced. I don't know how many of you have used Docker init here. Okay, I do see only 3 or 4 hands, so I think I am the right platform. We do have a demos for that. We have a Docker init, which basically today, even if you are writing a Docker file or Docker compose manually, I think you are missing a tool called as Docker init. Docker init creates automatically for you. Then we have a compose file watch, which is more like whenever you make any changes in the Docker compose file, you always have to restart those services. With file watch, you don't have to do it. The system automatically do it for you. Then we have a compose include. Say if you have, say, 10 different services. For example, you are building some kind of an observability stack, Prometheus, Grafana, C Advisor, and all of these things. And if you really want to go ahead and just include those, if your Docker compose file is growing, what I can do, I can create a separate compose file, and then I can use include feature. So include, what it will do, it will just save your time as well as it will the Docker Compose is not going to be a lengthy one. You can squeeze it, right? So these are the new things which I've introduced. There is also a Compose profile. Say if you want to use Compose for different environments, say dev environment, production, testing, right? You don't really have to create a separate file. You can use Compose profile where you can specify, okay, this services has only to be started when it is specified. Say for dev environment, these are the set of the services, okay? Now, there has been a lot of concern about the performance on Docker Desktop for Mac, especially. So we introduce a VertioFS. Whenever you do a bind mount, there is some kind of a performance bottleneck. So VertioFS solves that problem. We have a gvisor, which means that from the host to the container and container to the host, how the data is going to, transfer, right? Those speed has been increased now. And for this, you need to always keep your system update, especially the Docker desktop updated. So if you are using a version which is like 1 year old, you will see all those performance issues. But with the latest release, all of these things have been by default been enabled, or the performance is pretty good right now. Now, in terms of security, we have a Docker Scout. How many of you use Docker Scout here? Anyone? No? So I do have around 5 to 6 slides, which I will talk about Docker Scout, how it is. But think of it as like Docker Scout is a tool or is a product basically within a Docker desktop, which helps you to identify the vulnerabilities and to fix it. And it also gives the remediation. And it is different from other scanning tool because it is not basically a scanning tool. It is more like how you compare your local software bill of material with all those real-time CVEs. So I have slides as well as I have a demo where I'm going to go through it. Now, the third thing, which is, it is basically, okay, we have an attestation, which basically checks your integrity of your Docker image. In terms of choice, we have a couple of things like Docker extensions. Anyone who have used Docker extensions here? No? So Docker extension is like, say, if I want to install Grafana, and if I want to customize the Grafana UI, I can build my own Grafana. So extension allows you to integrate a third-party tool on top of your Docker desktop. Okay. The similar goes with all those different cloud deployment, cloud development, all those tools. And then we have an orchestration. Yes, we do support Swarm and Kubernetes, which means that if you really want to start with single node Kubernetes cluster, you don't even have to install kubeadm. It's already there. You just have to go ahead and enable it. We have a Docker sponsored open source projects, which are basically validated by Docker community, which ensure that your all the vulnerabilities, as well as it ensure that your image is there, it's working fine, right? Anyone who heard about Rosetta 2? No? Okay, so right now if you see, most of these MacBooks come with ARM processor. Say if you have built something around 3 years ago, it might be an Intel chip. So your Docker image which you built on your laptop might not work on your Raspberry Pi, right? Because it has to be built with the ARM architecture. So Rosetta 2 is the feature of Docker Desktop, especially for the Mac, and that has been integrated with Docker Desktop, which means that today, if you want to run ARM-based images on your MacBook, you can still, or say Intel x86 based images on your ARM MacBook, Rosetta 2 can help you on that. And then we have a WebAssembly awesome, which is again trending. There are a lot of conferences which is happening. So we do support around 6 runtimes. This topic has already been covered in the last meetup we covered completely. It was on Wasm. We have a couple of talks, but yes, we do support Wasm. Now coming to the new DockerCon announcement. Anyway, I'm going to touch base on all of those, the tools. But this is something which is coming with a new DockerCon announcement in terms of speed. The Compose file watch, which was like alpha, now it becomes a GA. So which means that now if you have ever used it, then it is by default, you don't really have to pass those X develop parameter. It is developed. So in a Docker Compose, there is a new section introduced called as develop. Okay. I do have I do have one demo for that. Then we have something called as a next gen Docker build, which means that today, if you are building a Docker image locally as well in the cloud, if you want to do it, how it is going to happen. So we haven't published, you don't have access right now, but if you want an early access, there is a QR code, which I'm going to share towards the end of the slides, which you can use it to basically access this and get an early access. But the whole idea is if you are building locally, we already have so many tools, but if you want to do it over the cloud, how it is going to look like. Then we have a Docker debug, which is again it's basically a debugging tool which has been introduced, and this is like a first class citizen. Again, it has been just announced, but for the early access, you just have to go ahead and register. In terms of security, Docker Scout was alpha earlier. Now it is GA, which means that it is by default available. So you can just go ahead and start trying it out. I know if you are working for a company which basically doesn't test the alpha version and they want a GA, for them it is useful. In terms of choice, today I'm going to talk about generative AI stack. This is completely new stack in collaboration with Llama and LangChain and Neo4j. We have introduced this stack, just one compose file, and think of it is like you want to run a chat GPT on your MacBook or Bard on your MacBook, how it is going to look like. So whole LLM, you can run it on your local machine. So I'm going to show you that particular demo. And then we have something new called as cooking up, called as a Docker AI. Again, there is not much information, but yes, if you need an early access, go through the QR code, access it, and then you can get an early access to it. But Docker AI, next gen, Docker build, Docker debug, these are the things which is still, we don't have an access to it publicly. But Gen AI stack is something which I'm going to cover, and I have written a blog around it. So let us get started. Okay, now since most of the audience is new to Docker, so I just thought that, okay, let's put this particular slide. So from 30,000 feet, if you know Docker, it's basically start with how you build, a Docker image on your Mac machine, how you share it to any of the container registry. It could be Docker Hub or say Azure Container Registry, right? Or ECR, right? And then one of your colleague or your the client might be pulling it and then trying it out or running it on their infrastructure. So this is from 30,000 feet. But as you go in depth into it, there are so many components in places. You could be a developer who might be using Mac machine, Linux or Windows, right? Different variants. You might be using number of IDEs, which could be Visual Studio, NetBeans or IntelliJ, and then you are making a code commit which is going to the GitHub action. This is basically your build server which you are using. This build server basically helps you to produce this Docker image, which you would be pushing it to one of the container registry, which could be the cloud or on premises. And then using the same Docker file, you can build, include it in your Docker compose file to build the microservices. And at the end of the day, what you're going to do, you started with a development machine. Now you want to go ahead and put it in the production. Now, imagine that you want to build a simple Node.js based application. This is the code, how you start, right? So what you do on the day one of your job, you just go ahead and clone your repo. You do some kind of a node package manager, npm init, npm install, and then there is some kind of get and post. You are just posting few of the messages and you are getting out of it. So this is a very simple way how you do it without Docker. Now, if I have to containerize this application, how it is going to look like? So for containerization, what you do, you start with a base image, which here is a Node.js. Again, we will talk about the best practices later point of time, but right now you can say from Node, it is very equivalent to Docker pool. You create a kind of a directory inside where inside the container where you want to put all the source code. You copy the package.json because that is where your all the Node modules are available, and then you do npm install to install the packages, and then the rest of the packages which you require, you can also copy it. You expose it to port 8080, and then you have server.js, which is basically the script which you go ahead and run it, right? Once you create this Docker file, you say Docker build and Docker run command to host, to basically access that particular application on a specific port. Now, there are certain do's and don'ts which you have to really think about, because now you are starting building those Docker images. You are pulling those open source images which you might not know. So usually what we do, from Python and we are done, right? But from where it is coming from? Is it a Python community it is coming from, or who is maintaining it? How secure it is? So there are do's and don'ts which we will go through. Especially I'm going to talk about 10 different best practices or image building best practices which you need to follow. So let's start with the first one. So whenever you are using any of the base image, always it is recommended that you specify this, you have to be very explicit. You have to pick up the very explicit Docker image. So in this example, you see here on the left hand side, it is a node latest. Now, this is a tricky situation. The reason being, whenever you try to build this image, it is coming from the node community, right? Or a Docker hub. And you don't know what changes has gone to it. So think of it as like today you built it and you went for a vacation and came back, and you might see like there are so many changes which might break your whole system, right? So it is always recommended that you use a very specific version here, say 16.17. Whenever you pick these images, ensure that it is very slim in size. The reason being, smaller, the whole beauty of the container is basically the smaller in size, right? That is the reason why we don't use VMs. Because say if I have to deploy some kind of a Java application on a VM size itself is 50 GB, right? Say if I'm putting it on Windows machine, my VM size is a 50 GB. On top of it, my application, so it might cross say 60 GB. In terms of containers, you can start with MBs. And you can see one example here where I have put an LTS slim. So it will be hardly like 66 MB. And on the left hand side, node latest, it might be like 600 MB. Okay. So smaller the size of the image, the more faster it boots up, and you get more and more good performance out of it. Multi-stage build. How many of you have used multi-stage build here? Okay, I see quite a few hands here. So multi-stage build, what happened that whenever you build an image, in between there are multiple stages, okay? And you will see in the multi-stage build how to identify there are multiple from statements. So which means that whenever you build an image, it also gets shipped with the build tools, which we won't require, because in the production environment, we don't want to expose our build tools, right? Which build tool it is used, which means that your image is, if it is like 600 MB, if you are using multi-stage build, then it might save, say you can save around 100 to 200 MB. The reason being, now we are not shipping it with the build tools. And that is the reason in this example, if you see, there are two stages. One is a build stage and one is a development stage. In a build stage, we have a different intermediate build tool which we have used, and we want to just skip it. So multi-stage build is used for the optimization if you really want to make your images slimmer in size. The other thing is, you have to be, if you see the first example which we have seen, right, from node, as I said, like we don't know from where it is coming from, right? So and since we are using a lot of open source tools, it is always recommended that we need to have some kind of, the vulnerability tracking tool, and Docker Scout is the one. Anyway, I'm going to cover this in the later point of the slide, but whenever you build any kind of an image, keep that in mind. And the beauty of Docker Scout is that it is not a third-party tool. It is already there. The moment you say Docker pull Node.js, Scout is already there. That's the beauty, right? Which means that you don't really have to install any kind of an extension. You don't have to install any of the software. It's already there the moment you just go ahead and build your image. And I will show you an example where I'm going to pick up some kind of a, Docker image, and I will see you then and there itself. I can see the vulnerabilities which it holds. I don't know how many of you know, you can use a health check in Docker file. So if you are really creating a Docker file, so in this example, you see there is an application which is exposed to port 3000, which is a simple HTTP server. I can use a health check. Now, this is really important. The reason being, say, and as you know, like health check can also be used in Docker Compose. So when you are using a same Docker image and deploying into the Kubernetes, in your pods logs, you can still see it. So the health check can be used here in a Docker file, and later point of time, it will be useful for the debugging purpose. So we do have a support for health check, and you can see here in the, once I run this particular container, then if you run Docker PS command, you can see the health check starting here, which means that it has started listening to this particular port. We have a .docker ignore, just like a git ignore. If you really want to go ahead and ignore those packages, one example in the Node.js is node modules, which you don't want to include all those node modules, so you can still use .docker ignore. It is always recommended that you always use run this container as a non-root user. The reason why you say container is not secure, the reason being, you are by default, any container runs as a root user, so you can use for the non-root user. This is really important, and usually we skip it. So whenever you create a Docker image, ensure that you create it for multiple platform. Most of the time we are in a hurry, we just want to create it, But imagine that your customer might be using any of the other Mac machine, or say if I develop some kind of an image and deploy it on Raspberry Pi or Jetson Nano, it might not work. Reason being, those are like an ARM architecture. So whenever you create any Docker image, ensure that you create it for the multiple platforms. And we have a tool called as BuildX, which can help you in building it. Using an open telemetry, most of the time it happened that you followed all the best practices, you build a Docker image, and now your Java application is slow or Node.js application is slow. So the reason being, you basically followed all the best practices, but you didn't go ahead and look into the APM tool. So there is one tool called as the Signals. You can use it. It can help you in finding the application performance. This is just one example. There are a couple of other examples which you can use. So it is always recommended that you use some kind of an open telemetry API. Again, as I said, you can use the health check in Docker Compose also. It will help you when you use the same Compose file to run a pods, and then you can see the logs there, where you can see whether this particular local host 3000 is listening or not. Now, this is what simple example. Think of it as like more complex example. So voting app application. Now, voting app application has around, say, 1, 2, 3, 4, 5 different services. How does the best practices would look like for such kind of an architecture? So you can see here, it's basically a voting app application where you have a front end, which is vote, which is written in Python. Then you have a Redis, which basically collects that vote casted by the users. Then you have a service in .NET, which retrieves that votes from Redis and store it in the persistent storage, which is basically a Postgres DB. And then the result, which is being displayed using a Node.js. Now, how does this best practices fit into it? The best practices are going to be the same, okay? In the same way, because when you start developing, right, think of it as like you have a voting app, voting team, you have a result team, different departments. They might be building their own Docker file. When they are building a Docker file, they have to follow multi-stage build. So the best practices which we have, it might be, I talked about Node.js. For Python, there could be other, maybe say 5 or 6, but the fundamental best practices are going to be the same. So for any specific programming language, there might be around 15 to 16 different best practices. But it is always recommended that even if you are picking up some kind of a microservices, those best practices are still valid. Okay, the open telemetry is still valid. Non-root user is still valid. Now, when we talk about the best practices, one of the things which you have seen, it is very hard. If you go to docs.docker.com and search for best practices, you will see a very lengthy page, which means that from a day one, do I really need to think about the best practices? Yes, but we do have a tool which can solve all your problem, and that is the Docker init. Okay, how many of you use Docker init here? I think earlier I asked the same question. Okay, I'm going to show you a quick demo here. So what does Docker init do? So there are 3 different components: Docker Compose, Dockerfile, and .docker ignore. What Docker init is gonna do for you is it will ask you few of the questions and it will create it for you. So it was introduced for the first time during Docker Desktop 4.18. It generates the Docker assets for you. It also helps you to choose the application program. So Docker init is powerful that it will scan your file system and it will identify which programming language you are building your project on. And I will show you in a quick demo how it identifies whether it is a Python, Node.js, all of this thing. And definitely this is something which you don't, because remember that when you write a Docker Compose file, you have to look at the indentation error, right? After a while, you will literally forget about how does the indentation error look like, how to fix it. And that's the reason I have seen a lot of people in the forum asking about why Docker Compose file is not being executed and all of these issues, right? So Docker init can solve your problem. And today, if you see, we do have a support for Golang, Node, Python, Rust. And in the last release, we had an ASP.NET. So if you are a .NET user, you can still use that. I have a repo where I have put all those different projects, especially a starter kit, which you can use. Now, we do have a support for Java and PHP. This is, I think, the most asked, there is in our, so Docker has a repo called as a roadmap. where you can just go ahead and say you can add your wish list. So what I have seen in the past, like Java and PHP is the next list. We have a C, C++, which is coming up. So all of these supports, which means that it is so easy for you to just go ahead and try it out. So what I have done here under the Docker samples, which is a public repo, I have a Docker init demos where you have all this list of Docker init sample application. So what I'm going to do, I will just go ahead and pick up Python. How many of you are Python developers here? Okay, so you can relate. But anyway, there are other examples like .NET, Node, right? So let me jump into okay. Can you see the screen? Yep. Okay, so let me jump into a demo. So what I have done here, I have already cloned the repo in order to save the time because I was not sure like how the network is going to look like. I hope I'm connected to the internet. Okay, so as I said, like there are different projects like .NET, Go, Node, Python. So I will just jump over the Python. I'm going to delete Docker file here, even a compose file. Okay, so right now, if you see so especially this is a very basic Python code, which basically displays the hello from Docker on HTTP server. So if I really have to run this, I can say Python 3 app.py and it gets started. What I can do here is go to localhost 8080 and it prints hello from Docker. Okay, so this is without running inside a container. So what I'm going to do now is I will going to stop this, and right now I don't have any Docker file, any Docker compose file. So what I'm going to do now is say Docker init. So once I do Docker init, it will ask you about all these programming languages, okay, the application platform. But the beauty is it has already detected your application here, especially the platform here. It says like what application platform, and it says detected suitable for a Python server. So which means that it has already seen that you have a Python code in this specific directory. Okay, I will just select Python. As I said, right, whenever you create a Docker file, it has to be based on the best practices. It has already picked up the stable version. Now the problem is whenever you start creating a Docker file, the first thing you need to know, go to the Docker hub, try to find out which base image to pick up. So it has already picked up the stable version. Definitely I want to run it on different ports, so I can just go ahead and customize it. Okay, I just made a customization. What is the command? So I will just say Python 3 app.py and done. It already created a Docker file, compose.yaml, okay, and .docker ignore. And definitely that you can see it right here when you say ls-la. Okay, so let us look at Docker file. If you ask me for this particular application, I will just write around 3 to 4 lines. But since it is a matter of best practices, you can see the lines. It has added around 50 to 60 different lines. Now let's look into what it has created. The first thing is, yes, usually what happens, we say from node and specific version, but the best practice is you always pass argument because it becomes very easy. During the build time, I can always go ahead and make the changes to this node, right? And then you can see here that you have to run it as an user. So you can see here it has already added a user for me, right? And then one of the other thing which you can see here is, okay, it has already added the bind mount. So the requirement.txt where you specify all these modules and all this thing, it has already mounted it because it is quite fast rather than copying it and then trying to do it, because the best practice is like it has to be with the latest feature like VertioFS. I think there is a lot of enhancement which has been made, so it is leveraging that. Then it is copying it, is exposing, and then at the end, based on my input, it has already added Python 3.app.py. So let us look at compose file. So as you know, the compose file is used for building the microservices. So what it has done, it has already added a service for me. I didn't write any Docker file or any Docker compose. One of the other thing what it has done, it has also created a backend or database entry also for me, but it is right now commented because I just have a single application, right? But the moment you have, say, Postgres or MySQL or any other database, it will automatically pick up that. Now, the only thing what I need to do here is Docker compose up -d. Okay, let me start Docker because it restarted, so it should not take much time. So the moment you do Docker compose up, it is going to start that particular service. And this is how the Docker desktop look like. Even I can see the images right here. There are a couple of images. I can say, let me look at the container, whether it picked up. It is still starting. Okay. So since the Docker desktop, let me see if it has already started. Okay, it is running. So soon you will see that this particular Docker compose file, what it is going to do, it is going to use a Docker file and it will start building it. Okay, now till that time, let me come back. So this is a repo, and if you are, say, .NET, how many of you are a .NET engineer here? I see one hand, two hands. Okay, so for .NET, what you need to do, just click on .NET, clone this repo, and you just have to go ahead and say .NET run, and then especially this is how you bring up this particular application. So what I have done is it's like a very simple student record application. By the way, I have been managing these repos, so if you have any query, if there is any issue, you can just reach out to me. And then yes, with Docker init, it will ask you about, okay, what is the name of the solution's main project? In my case is like my web app. What version of .NET is going to ask, and what local port. So this was very recently introduced. So right now, it's based on the speed, it is trying to build it locally, but it should be quick. In the same way, we have Node.js based application. You can use the same thing, Docker init. It will ask you and ensure that you install those dependencies earlier with an npm install, and then you should be able to access it. I am planning to add Java and PHP since it is not public, but maybe in the next release you will see that we will support that. Okay, so till the time it finishes, then let's go back to the topic and try to see, because there are a lot of things which I need to cover. We'll come back to that. Okay, so how many of you use Compose Watch? Compose File Watch. How many of you use Docker Compose? Okay, so Docker Compose is used to build the microservices. So you have a monolithic application, you have microservices where tons of services which is talking to each other. So usually what happens, whenever you use Docker Compose, just like I have shown, right, there is one service, Python based service, and it is starting up, right? In the same way, we have a Docker Compose. What it does, basically you specify multiple services, and the file watch, what it does, whenever you make any changes in one of the service, you always have to go ahead and reboot it manually. With file watch, you don't really have to do it. So what it does, there are two actions which it goes through. One is a sync and one is rebuild. In a sync, whenever you write a code, you basically run the container and you try to mount it onto the host, and your project or the source code is sitting on your host machine. You make any changes and that gets reflected inside the container. Now in the sync, what happened that whenever you make any change, it automatically sync to it. In a rebuild, what happened that whenever you make any changes, say in one of the requirement.txt, I made the changes, you don't really have to manually reboot your complete Docker Compose. It will automatically, it will basically watch your file system and make the changes for you. So for this, I have a quick demo here. So as you have seen, Docker Compose is up. You can see here the Python, there is a server which is running. I just have to click on it and it's there. Okay, especially in the Docker init. So it took me, I didn't write a Docker Compose, no Docker file. It's already there. And I just say Docker Compose and it is up and running. Okay, now let's jump to, so what I'm going to do here, I'm just going to go ahead and stop it and then delete it so that it don't conflict with any of the other demos which I have to do. Okay, so to show you example of Compose Watch, I've already cloned something called as Avatar. Okay, we call it as an avatar, but in US they call it as an avatar. Okay. Okay, so what I'm going to do right now, I have a compose file, so I'm going to show you how it works. So in a compose file, it is a very simple API, and then web API, your front end. So I can show you how the repo look like. So if you go to github.com/docker samples, so this is a very small sample project for demonstration. We use for demonstration. It consists of Python web API backend, which generates an avatars, and then we have a JavaScript, which is like a single page front end. All you need to do is again, this is the same demo which we use for the Kubernetes. Also, it can take the same application deployed in the Kubernetes. But what we are interested is this particular compose file. I don't know how many of you can see this, but let's look into it. There are two services. One is an API, and the other one is a web. I have few of the images which I have specified. There is a context. My Docker file is under deploy API file. Now this is something which I am interested on. So there is a new parameter introduced called as develop. Under the develop, I'm saying watch. So it will start watching my file system, or if there is any change. So right now, if you say the condition which we have, especially it is a rebuild condition, as I've shown you, right? Sync and rebuild. So under the rebuild condition, what I'm saying, whenever there is any change which happens in requirement.txt, Docker Compose should be intelligent enough to automatically restart service for me. Okay, so let me go back here. And what I have done is we do have a make file here called as compose. It will run Docker Compose watch. So there is a new command called Docker Compose watch, which has been introduced. So I will say make compose. Once I do make compose, it will just pick up the compose file. It will identify all those services. It will bring up the services, whatever the volume, networking, and then the new develop parameter which we have specified, and then it will start watching your API directory. Under that API, we have a requirement.txt. Okay, so most of the time, as a Python developer, what you do, you start adding modules, you make changes in the code, and requirement.txt is one very crucial file. Rather than saying pip install every time, you put it in the requirement.txt and say pip install -r requirement.txt, right? So right now, if you see, there are API and web are up. There is a network which is up. Your container is getting up. I can quickly see here. So in the Docker desktop, you can right now, rather than in a CLI, you can also, the UI, you can just go ahead and, control it. So I do see these are the services which is up. I updated my Mac very recent, like yesterday. So it might have some issue, but this won't stop us. So right now, if you see, under the API requirement.txt, it is saying I'm watching it. Okay, the system is saying I am watching it. Now let me open a new terminal here. Okay, go to my demo folder, API, and then what I'm going to do, I will go to the requirement.txt. There is a small web server. I'm just going to go ahead and remove it. Okay, now since it is watching the requirement.txt, the moment I save this, let's see what happened. I saved it. It triggered that there has some kind of changes which has been detected, and it will try to rebuild it, and it will ensure that your application is up and running. Now these were the manual steps which you used to do when you were making any changes. Now imagine that you have 100 of services, and if you make any of the changes, what we need to do is say if I have a front end, back end, and database, there are 3 different services. If I make any changes in the database, I always need to go and say Docker Compose restart that particular service, which you don't really have to do it. So this is a very recent feature which we have introduced, and it went GA. I would suggest you to just go ahead and try it out. You will love this because it is saving a lot of your time. Okay, sounds good. Is there any question which you want to ask? Any other question? Because I want to jump into the new topic called as Scout, and we have a Gen AI. There are 2 different topics. But if there is any question, just let me know. Anyone? It could be anything. Like, don't forget about like whether it is very beginner, intermediate, or advanced. You can ask anything. Okay, maybe I don't see any hands, so maybe later point of time I can pick that up. Yeah, yeah.
The Docker init that you are showing, right? Does it also support scratch inputs?
Which one?
The scratch inputs. You start from the like registers.
Scratch, yes. If you look at this particular Docker init, let me show you. This is a very good question. So anyway, I'm going to stop this one. Okay, hang on. Come on. Okay, so if I go to demo, Docker init demos, and if I say Docker init, you can select ASP.NET, Python, Node.js, and there are options called as other. So you can select this other one. Okay, so think of it as like if you want to build a Docker file or Docker compose file for C++, which is not there, right? You can use this. And in other, it will be more like, again, specific. It will just create a kind of very basic Docker file for you rather than specifying from or something like that, but ensuring that it is based on the best practices. Okay. Okay, fine. Any idea about the timeline? How much time I have? It's over? Don't tell me. Okay, so there are two topics which I want to cover quickly, and then we can come back. How many of you have used compose include? No? Okay. So this is one of the examples. So compose include is like, say you have 100 of those different services. I can create 100 those files, or say compose file, and then it can be picked up in a single file. So this is one example where I have a front end and the back end. So one example which you can see here is a web YAML where I'm saying, okay, include postgres.yaml file. So it will be automatically be included. So which means that your Docker compose, so it is basically referred to as a multi-YAML based Docker compose file. You can specify, think of it as like, if I'm building a Prometheus stack, I could have a Prometheus, Grafana, C, Advisor. So what I can do, I can finish this Docker compose file in say 5 to 6 lines where I can say include grafana.yaml include. So you can specify the multi-YAML. Now this is one of the asks which is coming from the developer saying like, my Docker compose file is getting lengthy, or it is very hard to maintain those Docker compose file. You won't believe that there are Docker compose files over GitHub which has more than around 3,000 to 4,000 lines of Docker compose file. Even that is there, and it is very hard to maintain them because Docker compose is one stop where you can have all the services which you can include, and then you can package it and send it to the customer, right? So I won't jump into a kind of a demo for this, but if you really want to try it out, there is a repo called as compose include demo, which I recently added, and I have given a very simple example of web.yaml here. You can see it here. Again, it says very old, especially for a Docker engine, but you don't need a version right at this point of time. What you need is specify the web as a service. You said depends on database because you ensure that database has to be up first and then your web application. But this is an entry. And when you say include post Grace YAML, what I can do, I can create a new YAML file and let's specify this particular service, pass the password. Again, it is not recommended to pass the text. We used to use secrets or something like that. But the whole idea is include can shorten your Docker compose file. So this is again the new feature which is introduced. Now that brings to me the new topic called as Docker Scout. So what is Docker Scout? So let us understand. And definitely keeping that in mind that it is not a security scanning tool. So whenever you compare it with other scanning tool, it is quite different. So when you talk about software supply chain, this is something, okay. When you talk about software supply chain, usually what happened that there are a lot of open source component which you use. So you might have seen the Node.js. We just said from Node and say latest or 16.17, we don't know from where it is coming from, right? So these open source components, we use it on daily basis, especially developers. And I will show you that only 9% of the developers knows that how to use these particular secure Docker images. Okay, this is based on one of the survey which one of the company, I think the Sonatype, they did a survey where they found that only 9% of the developers know that how to really secure your software supply chain. So all of these softwares has vulnerabilities. It might be the known vulnerabilities, it might be unknown vulnerabilities, and then, as you know, there are multiple number of developers in a company like Node.js, Python, .NET, and they might be contributing to some kind of a code inside and outside the organization. Now, the challenges is that this is based on the survey. 96% of the time, you have an application which includes your open source component. 96% of time, even when you start with the open source, any of the project on the day one, you always just think of it as like even the containerizing an application. You might be using open JDK as a base image, right? That is coming from the open source community altogether. And then out of those 96%, there is 70 to 90% of this code is in the form of the open source, which we all agree. They found that there is a 300% increase in supply chain attacks in 2021 itself. Okay, which is a massive number, which means that today you just can't blindly pick up any of the Docker image and start building it, right? So given the condition, so it is important that every company should know who is building the software, uh, uh, what's kind of a software you are running. It should not be like, think of it like I did pip install -r requirement.txt, right? I listed the modules, but no one asked me from where it is coming from, whether it is coming from the community. It might be the open community. Say you are installing some kind of an Ubuntu packages using apt-get or Alpine packages with APK, right? You don't know from where it is coming from, right? So there's a lot of huge risk which is involved, and it becomes important that we fix those risks. So Docker Scout come into the picture where it will understand your application dependency, it will analyze the vulnerabilities, and the best part is it gives you a remediation, and it becomes so easy. And this is important as you grow inside the organization. When you recommend some kind of a software, it is always important that you use Scout. And for all those Docker sponsored open source software, Scout is already there under the free plan. You can use it. Now, Scout is a new command. It's a new product. You can go to the CLI. You can even, not only in the Docker desktop, you can also use in the Linux machine. If you have an Ubuntu, Fedora, you can still use the curl command, install it. You can especially identify the vulnerabilities. Now, let me quickly jump into the demo and show you what's the power of Docker Scout here. So I have, we use very standard repo, Scout demo service under Docker. It is public repository, and it has a very simple app.js. It is, again, very simple hello world example, which I'm going to pick up. So let me jump into it. So right now, what I'm going to do, I have already a Scout demo service here. Let me remove this and clone it back so that I can show you quickly example. Okay, so what I'm going to do, I will say Docker build Scout demo, and I will mark it as, because I already have a Docker file which builds this particular application which I have shown you. So it is building a very simple application, right? And the moment I build it, you will see that at the end of the build process, you will see that there are specific Docker Scout command which gets displayed saying like, okay, you have built it. Now you can instantly check the vulnerabilities. Now, as I was talking about how different it is from the other scanning tools, so what we do, we have a concept called the software bill of material. So you can see here, this is a build detail and view the summary of image vulnerabilities, which means that I didn't install anything here, just Docker desktop. So when you install Docker desktop on your personal computer, Scout is already there. Okay. And the other way around is you go to the Docker desktop and you can see this is an option where you can just go ahead and analyze these images. You can just click on analyze image and you can do it. Now, if you see, I built a Docker image called as Scout demo. And I was talking that it is different from other scanning tool. So I can click on it. I can go to the images, click on Scout. So let me show you. So this is tagged as version as 1.0. I can click on it. And as I said, Docker Scout, what it does, it basically does layer by layer vulnerability check. Okay, layer by layer. And you can see here, there are 9 layers in this particular Docker file, Docker image. And the layer 5 has a vulnerability. Okay. Now, I can quickly get into the layer 5. I can see there are 2 other packages which are affected. One is Express. And the beauty of Scout is that once I click on it, I can see the CVSS score. So what it does, there are around 17 to 18 different real-time CV databases, which basically it tries to, your local SBOM will try to match those real-time CVs, and it will track those vulnerabilities, identify those vulnerabilities. And I can see there is a written like, it is written like the fix is in 4.17.3. So what I'm going to do, I'm going to open this. I will go to package.json, search for Express. So let's make the changes to 4.17.3. I'm going to make those changes, and let me build the 2.0 version, because now I'm expecting that those vulnerabilities should be fixed. My layer 5 vulnerabilities has to be fixed, right? Because I already seen that it has given me the information that the fix is in particular version. So let's wait for some time. Look at the image. It should come up quickly. Since we have only make the package change, it should not take much time. So right now, if you see, there is a 2.0 version here. I can click on it. And by now, you will see that layer 5 has already been fixed, which means that at least out of the 2, there is one vulnerability which I have fixed it. Now, the other vulnerabilities, which is quite serious here, which is in the base image, the base image itself. Okay. Now, the base image is Alpine, right? Which is again a smaller size Linux operating system. So we are using Alpine based base image. Now, as I said, right, Scout can identify the vulnerabilities, but it can also fix it for you. And the fix is based on the remediation. So on the top right, if you see the recommended fixes, what I can do, I can go to the base image and I can see here which of these images, particular version of images has a fix. So if I pick up 3.16, there is a 0C, HML, high, medium, low. So all these vulnerabilities will be fixed, right? So let me go back to my Docker file. Okay. And what I'm going to do, I'm going to pick up, say, from Alpine 3.16 and remove the first line here. Okay. Just to ensure that I picked up. So you can also copy it directly from here. So this time, when I am building the Docker Scout image, I will mark it as 3.0 to make it, 3.0. Now this will ensure that all my packages or the vulnerabilities been fixed. Now this is going to take time. You know why? Because now we change the base image. So for base image, again, it has to go to Docker Hub, pull those base image, and that is why it is taking more time. The earlier one was just like a different package. We were not making changes in the base image, right? So soon you will see that all the vulnerabilities get fixed, and I can clearly see it in the images that 3.0, where you can see that all are green in size, which means that your all vulnerabilities are fixed. So Docker Scout can help you identify the vulnerabilities. Okay. Now you might be wondering about, okay, I'm using a lot of other platform, how to fix those vulnerabilities. So Docker Scout, we have a command called Docker Scout CVS. I've also created kind of a cheat sheet where you can just go ahead and look at all those commands. But Docker Scout CLI today has an integration with all the CI environment. I have published a blog post on 2 of them, GitHub Action and GitLab. We do support Jenkins, Azure Pipeline, Circle CI, Bitbucket. Okay. And quickly I can show you how it look like for the GitHub action. Let me see. So I have an example of Scout demo voting app application, and you can see here. Okay, let me see if I have the services one. This will be easy. So if you go here, what I have done, I have created a workflow for Docker build. So usually this is how the GitHub workflow look like, where I am just specifying that if someone raise a pull request, if there is a vulnerability, then at the same time, what you need to do is the moment the vulnerabilities is identified, don't accept that particular pull request. So you can control your pipeline then and there itself. So I can quickly show you an example here. If you go to the action, so what I have created two branches for demonstration. The first one is the main branch and this is the fixed branch. Let's look at the main branch. So the similar way how we have looked into Docker desktop, you can also see the same thing right here on a GitHub action. You can see the vulnerabilities. You remember that there was a vulnerabilities in Express, right? Which the fix was 4.17.3. So right now on top of GitHub action, because GitHub action is also used to build those Docker images. So this is one example how the CI environment look like, right? And then if you look into the actions, if I, after the fix, this is the fix branch which I have added, where I have fixed those vulnerabilities. If you go here, you won't see any of the vulnerabilities. All the vulnerabilities have been fixed, right? In the same way, there is an example of GitLab. So if you go to Docker, Scout, GitHub, then you might end up in one of the blog posts which I authored. So let me search for Collabnix, GitHub actions. Yeah. So this is the one which I had, how to integrate with the GitHub action. There are a number of places which I have added, but you can look at all those integration stories right here. We have a GitLab, Microsoft Azure, Circle CI. So all those templates are available. So if you really want to try it, just go ahead and try it out. I know we are running out of time, so there is one topic. How many of you have working on Gen AI here? But I will spend around 5 minutes. Okay, there is one hand. Okay, two. Okay, fine. Anyway, it was not under the scope. I just added it last night because I was working on Gen AI stack. This is a very recent announcement. I am not a kind of a data scientist here, but I do understand Docker Compose and how to run it locally. Now, everyone is talking about LLM here, right? Large language model. How many of you use Chat GPT here? Oh my God, all the hands. Because it automates your tasks, it solves for you all the time. How many of you use Chat GPT for even writing emails? Okay, fine. Yeah, it is a brilliant tool, I would say. But there are certain problems, okay? Especially on the Bard. How many of you use Bard, Google Bard? Yeah, it is also quite promising. So everyone is talking about LLM. Okay, LLM is a large language model, which means that earlier it was an AI which you have a massive data and you are making the prediction, right? Especially in ML. Now, these tools which are available are so intelligent that, especially LLM is more intelligent that it can even write poem for you. It can help you do most of the tasks, especially when you go to Google and search for something, right? There are multiple queries and then you have to select it, but these LLMs have a massive data, and that is why they are so intelligent that they can automate your tasks. They can be a developer. So think of it as like you have hired some kind of a data scientist for you, or you have had a developer who can do a lot of things for you and exactly give you the solution. But if you look at these models, this is one of the picture which I picked up. Sorry, I just didn't add it to the source, but this is very popular way of how the LLMs has been used, especially in the text generation, classification, knowledge answering. You just, one of the beauty of ChatGPT, which I have seen, I told it, right? Okay, consider that you are a Mac machine, Docker is already installed, Kubernetes is already installed, give me the result and gave it to you. How relevant it is, again, you will find it out. But this is the all areas. This is how the spectrum look like. We have seen the popularity of Chat GPT and all of these things. Again, they are very popular. which basically it retrieves, data from all across the globe. ChatGPT is intelligent enough till 2021, but again, if you have a licensed version, you can get the latest GPT 3.5. But the whole idea is today, Gen AI is almost used in all the platforms. Microsoft is using it, Google is using it, Amazon is using it for the product recommendations. So there is a lot of popularity. Again, it requires 1 hour of session just to talk about generative AI. But there are challenges. The challenges is, I don't know how many of you have tried it out. Just go to ChatGPT and say like, okay, how much experience I have, and it will say like, based on the data, it will say 5 years. And the next time you say, okay, but I have 7 years experience. The next time when you keep on repeating that, it will say, yes, you have 7 years of experience. Okay, so it will always try to go ahead. There are certain challenges because this is the data which is stored there, but it is not intelligent enough to just give you an accurate data. And that is the reason why why you have seen there is a lot of companies who are backing up. They are not saying they are not going to use it, because most of this data. So today, if you write any of the query, and then you see the result, it might be coming from few of the websites, or the system is so intelligent enough. So people are hesitant because there is a lot of wrong data which is going there, right? And we have learned through the number of interaction which you use with this. So companies are really hesitant today, because today, even if I go ahead and ask about Docker init, you might think like it's the latest stuff, but again, even the Bard, which gives you all the latest information, it might be wrong, right? So which means that data is already there, but it is stored somewhere which you are not aware of. Okay, and the whole idea is, can I run these platforms locally on my MacBook? Yes. And that's where your Gen AI comes into the picture, especially the Gen AI stack which we are working. Because company cannot rely on these LLMs on mission critical data and decisions, and that is the reason. And this is one example here. One of the question asked is, who won the World Cup in 2022? It's Argentina, and that is the truth. And no one else won the World Cup. Yeah. So if I ask who won the World Cup, you will say Argentina. Yeah. Who won the World Cup? And say France. Okay. So all of these things, there are certain, and people have started realizing it as you talk with ChatGPT or Bard, just like a LLM models and all of these things. There are limitations. Knowledge cutoff is there, and then ethical. You can't query about any other person. But what you have seen, even if I go and say who is Ajeet Singh Raina, it will display all this my information and all of these things. So again, it is all about the prompt. What you and there is a better way. How about if you can host this data locally? Definitely, you need GPUs to execute it, but with the new collaborative effort. Again, in the next meetup, I'm going to cover and go in depth into it, because I don't know like how many people know about the Gen AI. Even I'm new to it, but the whole idea is Docker was working in collaboration with Olama, Neo4j, LangChain, and building something called as a Gen AI. These are basically the different tools which come into the picture. Neo4j, how many of you have heard about Neo4j here? It's a graph database. Yeah, it's a graph database. Mostly when you have mostly I have seen like when it is a more complex way of how, say, one example is a sensor values. If you are getting if you want to run some kind of a query, want to understand the relationship in between the nodes, right? So those things becomes easy with Neo4j. We have LangChain. Again, I haven't explored much. What I have known since this announcement, the Docker official image for Llama has really, it was just like around last week, it was around 4,000 Docker pools, and now it is like close to 10,000. It is 9,200, something like that. So there are a lot of people who have started using even the repo, which we open source. It has now even crossed 600 stars. There's a lot of interest. And again, one single Docker compose to deploy LLM locally. This is the whole intention. You will, if you have used, whatever the example which I have shown, it is the same example. So what I'm going to do, there is a kind of a repo here for you to try it out on your Mac machine. Again, try it with a CPU, because we don't have a GPU on the MacBook. So if you want to use GPU, go for Jetson Nano or something like that. But I will quickly show you how the Docker compose file look like. So this is a simple Docker compose file to build LLM locally on your MacBook. There are different services. So if you have seen, I can show you this particular Docker image. So if you go to the Docker Hub, I don't know, I haven't checked in the morning, but it is 9.7K Docker pools, which means that there is a massive amount of interest. Believe me, when I was going to DockerCon, it was 4K. Okay. So with the Gen AI stack announcement, there is a lot of interest. I was talking about this. So we have a database here. Again, as I said, best practices, health check. It's already there, right? Network, Xdevelop. I think we need to make the changes. They haven't changed because now this is a compose file watch. Now, whatever I said, you can see the implication here, right? Everything is being used in the simple Docker compose file, right? Even the Xdevelop is now developed. I raised a PR request to make the changes. And here we are just, whenever there is any changes, just go ahead and rebuild it. And there is a bot. One simple example, which I'm going to show you here, what I have done, I have already, I don't know whether it is running. Oh my gosh. Let me see. Again, I know we are running out of time, but let me see if I can bring it up. There are a couple of things. Okay, Orama is already there. I will say Docker compose -d. Let's see if it brings up the Gen AI stack. I just tried it once and it worked. But again, it needs to bring all those. If I have all these images there, I think it should be fast. Let me check. Yeah, I think almost all the images are right there. I will just delete this part and wait for it. Okay, till that time. Yeah, so these are different components. And the whole idea is what I'm going to do. If it works, I will just upload my resume and run a query. And it will give me the information about how many years of experience I have in this particular company. Okay. Now, this data is something which you can trust because you are providing the kind of a data to the system, rather than going to the chat GPT and asking, because you don't know from where it is coming from, right? But when you have a local LLM, which means that from the data from where it is coming from, you trust the data, and on top of it, you try to run the queries. So that's where the enterprise is going. So it has already started. So GenStack is up. Let me run this application again. Right now it is running. One single Docker Compose LLM is up and running. So let's wait. I don't know how it is going to work, but let's see. Again, 2 more minutes. I think we should be done. I would suggest it if you can run it on GPU. I think that would be more faster, because anyway, on your Mac machine, already you have a Docker desktop, which is up and running. So if you see here, this is basically one part of the Gen AI stack, which uses, you can chat with your PDF file. So what I'm going to do, let me search my resume and let's see if I can upload it. Okay. I know where it is. Okay, so this is my resume, which I have uploaded to the system. And soon you will see that I should be able to chat with my resume, which is in the form of the PDF. I'm chatting with my PDF. So I'm saying like, how long Ajeet worked in Delhi MC. And I say enter. So the whole idea of why you want to run this local LLM is that, let me see, is that you trust the data, the data, because I uploaded the data, right? And I'm writing a query on it. Think of it as like Docker desktop, if it has to be implemented in terms of, say, troubleshooting tool. So I can push all the error messages and I can get the result, right? I don't know. Yes. So it says, based on the information, Ajeet worked at Delhi MC a total of 4 years and 9 months, and there is a breakdown. So it just went to the resume, picked up my information and displayed it, right? Which is quite right, because I was there for almost 8 years. So it says 7 years and 6 months, the accurate one. So which means that this is how you can deploy the LLM. Definitely, this requires around 1 hour of time to go through it, but this is one of the major announcement which was made during the DockerCon. And if you are really interested, you go to the GenAI stack repo and start contributing to it. As a reference, I put all those Docker init, Scout, CLI. The Scout CLI, as I said, right, it is, you can run it on Linux machine also. File watch, these are the links. And with this, I think I took sufficient time, and we are late in the schedule, but let's see how we can manage this. But thanks a lot. By the way, I will be here. If you have any question, you can definitely ask. So with this, let me
Hey. Hi. Are you ready?
Yes, I'm ready. Do you want me to try sharing before?
Yeah, I'll just remove myself and you can start sharing your PPT. Can you just share your PPT? I'll put it on
Yeah.
stage.
Let me share screen.
Requesting everyone now.
Share screen. Entire screen, screen 2. Let me know if you can see. Yes. Okay.
Yeah,
Perfect.
I can see.
So
Okay, I'm removing myself. So we will just restart it. Okay.
Okay. Thank you. Okay. We'll go in presentation mode and start. I'm gonna be talking. My name is Gianluca Mardente. I'm a principal engineer at Cisco Systems, and I've been working on Kubernetes for the last 5-6 years at Tigerverse, which is the company behind Project Calico, and then at Cisco. And on the side, I'm maintaining this project, which it's an open source project. It's called Project Sveltos. And this is what I'm gonna essentially talk today. When you create a Kubernetes cluster, as you know, you have to install a bunch of add-ons and applications to make it a production cluster. Now, if you have a fleet of cluster, this means that you require some way. Yes.
Can you just be a little louder?
Of course, yes.
Yeah.
Let me know if this is better.
Yep. That's it.
Okay, thank you so much. So when you have a Kubernetes cluster, clearly you have to, I was saying that you have to install a bunch of the UK cluster, you have to install a bunch of add-ons and applications to make it a production cluster. And if you have a fleet of clusters, that means that now you require a way to programmatically manage all your clusters because you want to achieve consistency, and you want to have like a central place where you can make those changes. Now, with respect to creating, upgrading, and deleting a cluster, there are tools there which are widely accepted, like Cluster API. And Sveltos is a tool that sits on top of it and tries to manage add-ons and application deployment in a fleet of clusters. So Sveltos sits in a management cluster. And from the management cluster, cluster profile is the main CRD that is introduced by Sveltos. And from the management cluster, Sveltos can be instructed to manage add-ons and application in a fleet of clusters. Now, Sveltos has built-in support for Cluster API, meaning that if you create like a Cluster API powered cluster, it doesn't matter which is the infrastructure provider. Sveltos automatically detects it and can manage add-ons in this cluster here. But any other cluster can be easily registered with Sveltos. The only thing that Sveltos requires is that there is a network connectivity from the management cluster to any of the managed clusters. The cluster profile is the main CRD, and it contains this section in its spec field. The cluster selector, which is a pure Kubernetes label selectors. And it's simply, in this case, it's simply telling Sveltos to find all the clusters which are matching this, which have those labels here, environment set to FE, which stands for functional verification. And then it has a list of add-ons that needs to be add-ons or applications that needs to be deployed in all the clusters that match the cluster selector. And those add-ons can be expressed as Helm charts. So there is a section for Helm charts. In this case, we only have one Helm charts, Caverna, with the version that we want to deploy. But this can be a list of Helm charts. It has a customization dev section. Essentially here, Sveltos can be instructed where to find the customized file. And then Sveltos will run the customized SDK on top of it to get those files, to get the resources that needs to be deployed and deploy those resources in all the clusters matching the cluster selector. In this case, Sveltos is getting this information from a Git repo, which is synced in the management cluster using Flux. And then there is like the policy ref section, because sometimes it's convenient to put information in a secret or config map. and then simply reference the secret or config map, and then Sveltos will take the content that it's stored there and will deploy it. I do have one example here where there is a config map, and in the data section, there is a gateway class instance, and there is a gateway instance. So if a cluster profile were to reference this config map, Sveltos will take the content of this config map, so the gateway class and the gateway instance, and deploy those in any cluster that is matching the cluster profile. Here I have slides with few animations that essentially summarize what the flow is. Sveltos is running in the management cluster, and we have 2 managed clusters now. And again, those managed clusters can be anything. Cluster API Power Cluster, or any clusters that you have that it's simply registered to be managed by Sveltos. We post in the management cluster a cluster profile. And in this case, what we're saying is find all the clusters which are set to environment production and deploy Caverna version 2.5.0. If we add the label environment production on the first managed cluster, automatically Sveltos is going to detect that this cluster is a match for this cluster profile, and it's going to deploy all the add-ons that are listed in the cluster profile. In this case, we only have Caverna, so Sveltos will deploy Caverna. Likewise, if we add the same label environment production in the second managed cluster, the flow will repeat. Sveltos will understand that this is a match for the cluster profile, and will deploy all the add-ons that are listed in this cluster profile. The same way that Sveltos deploy add-ons and application, Sveltos withdraw those add-ons and application if needed. So if we were to remove the label environment production from the second workload cluster, Sveltos will detect that this cluster is not a match anymore, and so it will withdraw all the add-ons and application that you had deployed. This is the default behavior, but essentially it is configurable because sometimes you can tell Sveltos that if the cluster is not matching, leave the applications at once that you have deployed. That would be the case where, for instance, you are creating a cluster and you are installing a set of add-ons and applications, but then you want to give the cluster to somebody else. And from that point on, they will manage the cluster. So in that case, you will instruct Sveltos to leave the add-ons and applications and stop managing the cluster from that point on. The difference, if you compare with a full GitOps approach, is that the add-ons and applications can be expressed as a template, and Sveltos is able to instantiate those templates at deployment time using information which is present in the management cluster. For instance, if I want to deploy Calico in all the production clusters, Calico might require requires, I don't know if this is still true, but it used to require the CIDR blocks to be passed to Calico. So one way of doing it with Sveltos is that we add the value section, and we express the value section as a template. I know that if I'm deploying Calico in a cluster API Power cluster, in the management cluster, there is a cluster instance which represents the cluster where I'm about to deploy Calico. And I know that this cluster instance in the spec cluster network pod CIDR block section, it has the information that I require. So what Sveltos will do in this case, it will detect that the value section is expressed as a template. It will fetch the cluster instance representing the cluster in the management cluster. It will instantiate this template, and only after instantiating this template, it will deploy Calico. So this instantiation will happen at the time Sveltos is about to deploy Calico in one of the clusters matching the cluster selector. And this is why it differentiates essentially from a pure GitOps approach. Here I have another example, because by default, Sveltos can fetch certain information like the cluster API resources or the Sveltos cluster representing, for instance, a GK cluster which has been registered to be managed by Sveltos. But Sveltos can be instructed to fetch any information from the management cluster, provided that Sveltos is granted like the permission to do so. So in this case, for instance, we are asking Sveltos to deploy in every cluster matching this cluster selector the content of this config map. But before that, we are telling Sveltos that he needs to fetch from the management cluster a secret, which is in the default namespace and which is called autoscaler. And after he fetches this resource, we're telling Sveltos identify this resource as autoscaler secret with this autoscaler secret ID, and then deploy the config map. Now, if we go and look at the config map, it's a template. So it's like there is an annotation as well telling Sveltos that the content of the config map is a template. And the data in the config map section, it's again, as I mentioned, is a template, but it's referencing the autoscaler secret. So since Sveltos has fetched a resource which is present in the management cluster, has identified this resource with autoscaler secret, now Sveltos can instantiate this template and can use information like the data token or the data CA/CRT, which is present in the information that secrets that Sveltos fetched. You can instantiate this one, and then only after instantiation deploy like in all the clusters that are matched. Because of this behavior, now Sveltos can be piped with other open source project. For instance, in this case, we have Cluster API, Sveltos, Crossplane. They're all running in the management cluster. So we can use Cluster API to programmatically create a cluster. So we simply post like the Cluster API configuration, Cluster API will instantiate a cluster. And then we can tell Sveltos, now we'll post a cluster profile, and this cluster profile tells Sveltos, create a crossplane bucket instance in the management cluster. Because Sveltos is creating this crossplane bucket instance in the management cluster, this will trigger Crossplane to go and create a Google storage bucket. And when Crossplane is done, Crossplane will update the bucket instance with information like the URL and the ID of the bucket that you just created, like in the Google storage. And Sveltos at this point can use this information and take the cluster profile also contains a pod template. And so Sveltos can fetch this information, which is coming from Crossplane, instantiate the pod template passing the bucket URL, which is taken from the bucket status, from the Crossplane bucket status. And you can deploy a pod in the management cluster, in the managed cluster. And at this point, this pod has all the information that he needs to access the bucket that we just created. And so, for instance, he can upload a file to a bucket. And with a simple cluster profile, we can have different cloud storage bucket created one per cluster and different like pods in every managed cluster accessing like the bucket which has been created for that specific cluster. Another example of integration will be with the external secret operator. The external secret operator is a fantastic like open source tool that allows you to fetch secrets from external secrets management system. In this case, we're using like the Google Crowd Secret Manager. So what the external secrets operator does, he fetches the secrets from the Google, from this external secrets management system, and he pushes the information, creating like a secrets in the management cluster. And every time like the secrets change, like in the external secrets management, external secrets operator detects the change and update the secrets here. And now Sveltos, because of its dynamic nature, can be used to take this to take like this information here and distributes to all the managed clusters. So you have now a centralized place where you manage your secrets. External secrets operator is used like to fetch this information and bring into the management cluster. And then Sveltos is used like to automate the deployment pushing to all the managed clusters. So all those integrations are possible because Sveltos essentially can read the deployment time information which is present in the management cluster. Another feature that Sveltos has is the ability to classify a cluster. So far, essentially what we have seen is that the platform admin is in charge of setting the labels on each managed cluster. But this might become an error-prone operation. So sometimes we want a set of add-ons to be deployed in a cluster if the cluster is in a certain runtime state. For instance, I might want to deploy Gatekeeper in all the clusters which are running a version of Kubernetes which is greater or equal than 124 and strictly less than 125. So Sveltos has a second CRD, which is called classifier. And the classifier is capable of classifying a cluster based on its runtime state. In this case, what we are saying is classify a cluster that it's running a version greater than or equal to 124 and strictly less than 125. If you find any such cluster, this is the label that the cluster should have. In this case, the label is gatekeeper v39. And I'm pairing the classifier with a cluster profile saying, if you find a cluster which has labeled gatekeeper 39, which is exactly what the classifier will add, then deploy gatekeeper v390. So if we push this configuration, this pair to the management cluster, Sveltos will deploy an agent in every managed cluster. These agents will detect that both clusters are a match for this classifier. And because they're a match for this classifier, we'll add this label here, gatekeeper 39, on both the clusters. And now because this label is added to the cluster, those clusters start being a match for this classifier, for this cluster profile, and so gatekeeper will be deployed. Now, what if I want, when a cluster is upgraded, I want to also upgrade the gatekeeper version? Let's say that if a cluster gets upgraded to a version which is 25.0, 125.0 or higher, I want gatekeeper to be upgraded to 310.0. I can post another pair of cluster profile classifier. So the classifier in this case is saying, find any cluster which is matching this Kubernetes version constraint, which is greater than or equal to 125. And if you find any such cluster, the labels that this cluster should have, it's gatekeeper v310. And I'll pair this classifier with a cluster profile that says, if you find a cluster which is matching this label here, the version of gatekeeper that I want is now 310.0. So what happens when this cluster here gets upgraded? So this cluster gets upgraded from 124.2 to 125.2. Automatically, the agent detects that the cluster is now, it's not a match for the old classifier anymore, but it's a match for this classifier. And because it's a match for this classifier, it goes and upgrades the Kubernetes, the label that the cluster has. And because this label has been updated, now the cluster starts being a match for this cluster profile, and so the gatekeeper version gets upgraded to 310.0. In this example here, I'm using as classification mechanism only the Kubernetes version, but you can classify Sveltos you can classify a cluster using any Kubernetes resources, and you can define your classification using a Lua. So essentially in the classifier, Sveltos allows you to pass like a Lua script and to tell run this Lua script against those resources. And Sveltos is able to detect whether a cluster is a match or not. I do have prepared like a demo if I should still have time, like 17 minutes, so I should still have a few minutes. So I'll share, like I'll come to this information later. Essentially, if you want to contribute to Project Sveltos as an open source, this is the GitHub, which contains a repo, which contains a lot of information, including the YAML for all the examples that I showed. Or you can find me like on Slack. I'm part of the Collabnix Slack channel, or there is a Slack channel for Project Sveltos as well. And this is where you can find me, like on LinkedIn. And I'll stop sharing and I'll stop these slides and I'll share a demo that I did prepare. So in this case here, I do, and I hope the font is large enough. I do have a management cluster. And in this management cluster, I do have, in this management cluster, I do have cluster API installed and cluster API infrastructure provider with Docker. And I do have Sveltos installed. The main component in this case is going to be the add-on controller. We're not going to use the other components. And I do have a Kubernetes cluster API power cluster, which is running version 1.27.0. Sveltos comes with a CLI. You don't have to use like the CLI, but in this case, like pretty much I'm going to use it simply like to show what add-ons or applications are deployed where. And there is absolutely nothing at this point. If I go back on the cluster and I show the label that the cluster has, the cluster has the label environment function verification is set on this cluster here. There are other labels, but this is the labels that essentially I care at this point. And I do have a cluster profile. I think I have this one presentation. It's this one. So I have this cluster profile here, which is saying that if there is any cluster which has this label here, I want you to deploy Caverno 301, which was one of the examples. The Helm chart version is different, but the example is the same. So if I apply this configuration to the management cluster, and I start looking at the add-ons that are deployed, we'll see that in a few seconds, the Caverno should be deployed in the managed cluster. Before I go there, I want to show something else. Sveltos creates an internal resource to do this tracking here. And it has created an internal resource saying that pretty much it's in this cluster here, it's deploying this cluster profile. So if we go back to the add-ons, now we can see that Sveltos has deployed Caverno version 301. It has deployed at this time. It was deployed in this cluster, which is in the default namespace, and it's called cluster API workload. And this is the reason why this add-ons was deployed, because pretty much there is a cluster profile Caverno, which is a match for this cluster, which is asking for Caverno to be deployed. I do have yet another example about the classifier. So I'm posting this classifier, which is saying, if you find a cluster which is greater than or equal to 127, add this label here, version 127. So I'm going to apply this classifier. Applied. And what we saw before is that the cluster is running a version 127.0. So because I applied this classifier, I expect that at this point, this cluster is going to have the label version v127 added to it. And also, I'm going to apply this cluster profile that says that if there is any cluster which has this label here, deploy also Nginx this version 0.18.0. So I'm also going to apply this classifier, and we can look at the cluster. The label has been automatically added by Sveltos. Sveltos has detected that this cluster is a match for that classifier, and I added this label. And because this label has been added, now Nginx is being deployed as well in this cluster. And of course, as I was mentioning, if I were to remove this cluster profile, I would expect that Sveltos will remove the Caverno from this cluster. So we can do that one as well. So I can do a delete of the cluster profile called Caverno. This, it has a finalizer because it has to wait for Sveltos to do its own cleanup, and as soon as Sveltos is done cleaning up and removing the withdrawn, which again, it's a configurable behavior. Sveltos can be configured to leave the add-ons when a cluster is glitching or when a cluster profile is removed. But as soon as this is done, if we go and look back at the add-ons, now the Caverno is not deployed anymore. So yeah, this is all I have. If there are any questions, I'm happy to try to answer any questions you may have. And if you find it interesting and you want to contribute, it's open source. I will love your contribution. I will love your idea. I will love your feedback. That will help make Sveltos better than it is today. So thank you so much for your time, and thank you for the opportunity. I really appreciate it. Okay, so if there are no questions, I'll stop sharing. Okay, thank you. Thanks so much.
Yeah, thank you.
Thank you. Thanks for the opportunity. I appreciate it.
Thank you.
Power नहीं आ रही.
Hello.
Okay, so next we have Sangam, and he's here to talk about the Threatmapper. Sangam, can you just switch on your video? Yeah.
Is it visible, guys? Yeah. Is it audible?
No.
Yeah. Is it what? Hello, everyone.
scanning in minimal. That's what matters in the security. How fast you scan once you connect the resource. So now you see management console. Now there are multiple. Now most of the people use Docker. Okay, some people use another container runtime, Cryo, or another container D. Right? We support all those. So you can connect those things. Otherwise, you can connect Helm charts. You can spin up using Docker Compose or Helm charts, Compose. After that, you can connect agent using this thing. Okay, once you can connect your serverless functions, CI/CD pipeline, your registries, no matter, everything is in console. Then you can connect your Kubernetes using Helm chart. You can create daemon sets, okay, on every node, spin up, and you can use any runtime to connect it as the host. Let's say you have the only Linux machine, C2 machine, and you want to put it. You just go and there install Docker and put it. Okay, that host is automatically. What if it's Kubernetes? You can use Helmchat, you can use daemon set. There is multiple ways as per your need and as per your resources or the practice.
Sangam.
So now you have the image vulnerabilities. So once you get this agent everywhere, we scan image vulnerability, whatever the container image, whatever the host, we scan everything. Next thing is secret scanning. We do secret scanning and malware scanning of both the infrastructure, not only containers. Then we go to this CWPP posture, we scan all those things, and we do kind of vulnerability research around. And then we come from the topology, how your whole infrastructure is like. You show in the demo like how spin up, you spin up the 2-3 environments. Now another thing is this is fine. Now you have a security team. Now security team may want some kind of alerts. Let's say you can add as many users you want in the console. Let's say you are admin of a security team. You can add your security emails. We have that integration also. Now you can take those logs as HTTP, REST API, whatever last use we have inbuilt it. So main reason of building this tool is most of the cybersecurity don't have the budget to build their own tool by themselves. That's why we came up with solution that how can we build one platform that can be used by any kind of that's the idea we started and now it's well adopted by a lot of companies. People run in production, this is production based. We support ARM also kind of agents. We use IoT, we support those kind of on-prem or cloud, no matter what it is. So one other thing is when I talk about topology of your own infrastructure, let's say I have this infrastructure, I can see all the process container inside the files, everything. You can go deeper into deeper. What we correlate how network is flowing around one entity to another entities or object or whatever the service is. Right? Now this way you can see event. Right, that way you can tackle very easily what happened, what happened, why are we using this content, how much process it takes. We are not only security, we do observability. We see how much CPU is utilizing, how much. There is, when I talk about topology, there is important thing is visibility, dynamic production. Micro segmenting is very important. Let's see, you have the e-commerce platform, right? You have microservice application. You can simply go and see in topology what microservice, what security threat is happening. Let's see where our DDoS. Let's see what are the IP, what are the requests, your inbound request, outbound request. You can track those whole things. Another thing is we have updated policy. Now another thing is SBOM. We provide SBOM of full infrastructure, not whole your threat. Whatever threat graph, correlate or threat topology is there. So whatever the dependencies using we scan them. Let's say you are using some application, but you are using third-party dependencies. From our platform, we scan third-party. That can happen from anywhere. So we scan those dependencies also. So that is one of the things already mentioned the agent based and kind of thing. So strength is here. If you use agent based, you can get accurate kind of things, right? When you take the CPU utilization, also we need to. If you are using offline, go with it. If you are using online, go with agent. It's connected to the cloud, right? It's have some data, but most of the people prefer agent based. Those who have more reliable on this kind of cloud environment and all those kind of things, they go to. But it's up to you what your strategy is, okay? How fast you want those things. Let's say you have cloud formation template. We have template, you can run those template as a scanner. Scan those things. You don't need to deploy any agent. So we do the vulnerability management when you talk about the vulnerability, is that I have seen so many vulnerability management. So let's say I scan my whole infrastructure, I got 8.4K vulnerabilities. Now I don't have the capacity to my team to tackle those 1.4K, or I don't know which is most important. So we use EBPM technology to tackle those most important things. We like from 8.4K, we automatically programmatically generate 1K is very important. You should remediate it. You can click here and then you will see CV's detail and you can remediate it. So this is very easy way to what most important thing. Let's say you have top 10 containers. So you can focus what most attack part of attacking your infrastructure, how you can solve it. Right? This is one part is vulnerability management at runtime. So let's I will just go to one feature and then I will show the demo, 3 demos that you will understand it more easily. Another thing is secret scanner. Now most of the container registries don't provide secret scanning. And our developer accidentally commit the secrets on production environment or their password username that can use and access. It's very important. When you do Docker build -t, whatever the context your current repository working, it take all the data or the configuration. So we scan 140 type of secret scanners. Secret scans, we show the results. And you can we use same methodology. Let's see a phone number how to most important one. Next is malware scanner. So malware is also very important. You see this, most of the companies get more high bills because of malware. They are running some kind of Bitcoin on your container inside your machine that can cause. There is recent incident I have seen is that some of the attacker blocked some of the e-commerce system, and for 4 to 5 days their whole business shut down. Right? It can be because we are running a business, it's and we need to see what happening in the whole infrastructure. The malware is very important kind of detection thing. Another thing is cloud posture management for your infrastructure. No matter what you use, as your AWS on Prime, you can write your own custom policies also and integrate to the platform. So you can do that also. So it's give you all the details. You can easily. Another thing is containerization. Now you see so many containerization. So you can connect directly containerization as your developer can push the image, we scan here, we scan here, you not need to check everything, right? Basically, your security team directly get alert. This is developer is doing. Another thing is I have seen most of the chat option of thing coming up. Now let's see if our file team can integrate with Slack. Let's say I have a file release, it should go to that team and that team should solve. All these management inside problems with this kind of integration, you can integrate it as email, as some vulnerability came, go to the security department of security guys, they will get email, they will fix it. This is very important, and you can have multiple kind of thing. Also, we added recently AWS security tower. So there is a lot of elastic search. Let's say you want to show the metrics and all those happening, so you can use that. You can generate this report. If you are CISO of a company, so they can use this data actually. So another thing is user management. You can add multiple users as much as you want. You just add it. We have debugging, cron job, scheduling, when you next scan to start. You need to do a manually kind of thing. You can define here everything. Another thing is that is one part. Another part is enterprise one. So we do in enterprise runtime incident management. Let's say that we take military attack where we correlate using and we let's say some DDoS attack happened. So we have the policies You can deny a block of that thing. It prevent from no matter your service mesh, Kubernetes, whatever. Support all. So let's see the demo. So first demo, I will go with very small kind of thing. So I have 3 cloud providers, AWS, simple Kubernetes cluster, okay, or any Kubernetes cluster deploy. So now you see in the platform is now you have a top. Okay, let's say I have internet and internet accessing some services from my infrastructure of company. I use GCP, private cloud, or AWS. So you can see attack path vector of whole infrastructure. So your security team can understand whatever the host, let's say 100 hosts you have, how many vulnerability you get. So we correlate this kind of topology out of your whole infrastructure. Also, let's say you use AWS, you can go and check whatever the cloud resource you are using, what are the services, you can expand the topology and you can see more detail around it, and you can get a kind of this kind of details of what vulnerability is getting, what process is using, right? Another thing is runtime incidents. So we, let's say runtime incidents happen, we detect those incidents. We create a tactic for you, for your security team, what should they do, what should they prefer. If you all those metadata about these things, here vulnerability, we scan whole infrastructure, and also we give a top attack path vector, how attacker can attack. We queue this path vector also, we scan vulnerability, top vulnerability container. Also we give a runtime SBOM, let's say you use some kind of a container. Inside a container, what the dependencies you use, those dependencies, what, let's say you use a dependency, what the dependency like log4j. So you should update that. So oldest dependency also we scan. Then we do a secret scanning, malware scanning, posture for your AWS. So you just need to go to connect and just take this template or configuration thing, automatically go to your console and you connect your agent-based thing. You scan all the resources what inventory you have. Then registries, you can protect the policies like block some IP and all from here. So integration, you can integrate different things. Now I will show how you can, if you want to try this platform. So one thing is you can do is first console. Let me show you directly. So I have 2 EC2 instances running. One is for the console. So always you need to deploy one console to have that UI. And to connect to that UI, you need to go to the settings, then connection instruction. So if it's AWS, it's Azure, so there is, you just need to click, let's say I will select a Kubernetes cluster, I get a whole script generated. Now I just need to select what the cluster name, what the container runtime I will use, just copy this file. It has one IP and key that's connected to this thing. So you can run those your whatever the thread, wherever you want. Make sure that your 443 port is open, and you should have console to run this console at least 20 GB. And we run this whole thing as a microservice, and your thing scale, our thing scale. So no matter what, how much resources you want to scan, you can scan. And it will scan, it will give you all the result. And we have the community Slack also. So you can go to the defense community. You can go to community.deepfence.io for all the documentation and everything. If anybody want to try, you can go to the documentation section and you see there. I created one read-only sandbox for you. You can go to this sandbox and use this URL password. It's read-only and you do anything, add any gesture there. So you can try out this sandbox. If you are doing this, looking for any tool, you can try this and let me know. We happy to support. You need any support. Any questions? Yeah. So thing is that let's say you use something like so we scan all those things. Your right, what is it? Let's say some of the people they don't want third party vulnerability. They have one vulnerability. They can correct their data. We use best vulnerabilities. We update CD from national database. So we get all latest CDs and we give a remediation also. So this way, I think it is easy for developer to understand. Kind of both the learning and scanning is important. You can use both. Any question? Dynamic provision resources in the sense. Yeah, so we whole thing is whatever we have in platform is microservice. So the auto scaling part is agentless. So we have the cloud formation template hooked to your whatever the we use something called EBPF technology, which go to the Linux kernel. From Linux kernel we scan it. So that way you get all the top your application, your code. Let's say you are using Java application, you can scan Java. Host to scan vulnerability, and when you come to kernel, we scan using eBPF system call, we get that those system call. Then let's say you have some packages, PCAP packages, we scan those packages. So using all this data, we correlate that out. Any other questions? Commodity perspective, let's say you have the complete of. So you need to go and check in this microservice how much is this flow. You show the process, you show the packets, no rule there, this whole thing. We give this data as the API. Partition SDK or code SDK, you can extract your data and put it into your tool. Use that as an engine.
Okay. Thank you, Sangam. We will have our next speaker, Apurva Bhandari.
Am I audible?
Yes, Apurva, you are audible. I'm just removing myself.
Okay. Hey, just give me a minute. You're able to see my screen, right? Hello.
Yeah, we can share see you the screen.
We can see your screen.
You can start.
Okay.
You stop your screen. Can you share again?
Yeah. Give me a minute.
Yeah.
Now I guess.
We can see your screen. Okay. We shared already. I put in now.
Just share your slides directly.
1 second.
You need to share a slide. You shared all.
Now is it only the slide?
No slide we cannot see.
I think you are sharing the entire screen. That is why it is appearing. Just go to the browser and start sharing your slides.
It is not showing me that option.
Can you click on present and then entire screen? Can you just do that? Go to the StreamYard, click on present.
When?
And then share your entire screen, or you can share the slides if you don't have a demo.
Yeah, I'm just sharing my whole screen.
Okay, hang on. Okay, can you open the slides now? Just go open the slides in the Google. Are you presenting in Google Slides?
Minimize this and open the slide.
No, he is sharing his own screen.
From here?
Share the link. Link or something we can do. Take a slide video. Yeah.
Apurva, are you using Google Slides to share it or PPT?
Yes. Google Slide.
Okay. Can you open the browser? Can you open the browser?
Yes.
I think you have multiple screen. That's why we are not able to see.
No, I have only one screen.
Can you minimize?
Yeah.
This?
No, I think he has multiple screen.
No. I have only one screen. Let me check.
Click on allowed.
Sorry?
Just click on allow. Allow pop up there, no?
In the StreamYard? Yeah, I already did it. Oh, okay. Let me check it from the another browser. I think it's not supporting.
Open in another browser and share that browser screen.
Yeah, got it. Just give me a minute.
Run the StreamYard in another browser. Don't close this browser.
Or else can you share a slide with us?
Hey, give me a minute. Oh, can I share my? I'll share with you. Whom I have to share?
Just keep it a public one, na? Public slide, and then click share it on the chat only.
Okay. This is a public link. You got my slide?
So Apurva, you can manage your slide from there itself. Okay, just check up and down.
1 second. Now. How can I go to the next? Or you guys are able to see my another screen? Sorry, another window. The Chrome
No,
one.
we can't see your another window, but now I think already slide is there. You can start.
How can I move to the next one?
You can start your presentation.
Okay. Hey, hello. Hi, everyone. Sorry for the delay. So today's topics is eliciting the Karpenter. Most of you have heard about Karpenter. Most of you are not. Slides are not shared. Sorry. Okay. Yeah, fine. So before we start, I would like to check you guys are using Kubernetes on the multiple clouds. It could be AWS, it could be Google Cloud, it could be some other Azure or something like that. But this is an Karpenter. It's I'm not sure you guys are already using it or you heard it or not. But let's see what are the things are there and how we can do it with it. Yeah, so this is about me. I am Apurva Bhandari. I'm currently working as a senior SRE in Tracelink. I'm also a Kubetool maintainer. For most of you guys are knows about the what is Kubetool, and Ajeet will maybe share the link of Kubetools. We have listed multiple tools, open source tools, which are available in this world on the single page. You can go, and if you like, you can give it a star. I'm also a speaker at multiple meetups. Yeah, you can connect me via multiple links that are posted. The next one. Yeah. So when you heard of Karpenter, do you guys like keep things in the mind that this is the Karpenter? You can comment in the comment box like, is this a Karpenter that you are thinking of? Then then it's not. It's something not Karpenter that today we are going to see. It's you can check the spelling. It's not a C. It's a K. Yeah. So let's jump into the Karpenter. What it is, and let's have a look at around it. So in the today's session, we are going to see what is autoscaling, then how node autoscaler works, then what is Karpenter, why we have to use the Karpenter, then some of the architecture diagram of the Karpenter, how it works, and then most of the interesting topic, Karpenter versus cluster autoscaler, Karpenter with cluster autoscaler, and advantages of Karpenter. Yeah, so I'll just give a not in the brief, but I would like to ask you if you guys are aware about the what is autoscaling. Maybe like I would like to ask one question to each and everyone in the audience, like what is scale in and scale out, and what is scale up and scale down? What is the difference between scale in, scale out, and scale up and scale down? Maybe the correct answer Rajit will give one some type of goodies to them at the end of the session. Like I would like to answer from you guys, like what is scaling, scale out versus what is scale down and scale up. Don't use your chat gpt to get the answers. Okay, so regarding the auto scaling, I believe like the guys, if you are using the cloud, or even if it is not, then you must have heard about the auto scaling. In the auto scaling part, like as I said, it could be scaling, scale out, or scale up, scale down, depend on the like what type of scenarios that you have, and think of in a way that like if this functionality is not there, how application will survive the traffic which are coming in. So that's the most interesting part while doing the any kind of auto scaling with your cloud provider. Another thing is like when you think about the Kubernetes world, it's again the microservice world, and we are running multiple microservices in this Kubernetes, and how you can scale them. And think in that perspective, now you're using your deployment, you deployed that in the Kubernetes, and how it is going to scale if I have only scaling which are inside the cluster. And what if like I want to scale the cluster? So in terms of like AWS provide the two supports to scale your cluster. Those offerings are one is Karpenter, another is cluster autoscaler. So cluster autoscaler is like is a classic example, or you can see it on the not only on the in the Kubernetes world, but in the monolithic, or if you are using any kind of EC2 instances in the AWS cloud, or in another clouds, then the instances that you are scaling up or scale down, those we can call it as a using the auto scaling group. And that functionality which we are using in the Kubernetes with the help of cluster auto scaling. So why there are like two things that we need to learn if there is a cluster autoscaler already there in place, and why I have to go for the Karpenter, or why should I learn that, and why should I go to the Karpenter, that we are going to see. So Karpenter is like the flexible high performance Kubernetes cluster autoscaler that helps the improve application availability and cluster efficiency. We'll see that in step by step. Might be you guys are already using the cluster autoscaler with the autoscaling group, And how it works, so it just there are a number of nodes or node groups that you have. For example, I have a node group of 3, and I have scaling from 3 to 5. So if there are some pods are in pending state, or they are in unscheduled state, that you need to schedule them on the new node. So if you want to see the holistic view of how cluster autoscaler work, then we can see it in the next slide. So here you can see, let's consider I have one EKS cluster and I have scheduled some of the deployment, which consider as a replica set of 3, and traffic comes in and they are increasing, and I have set an HPA to from 3 to 5, or let's consider 3 to 10. In the again auto scaling group, I have set an node from 3 to 5 based on the what kind of pods and what type of resources I have given to my deployment. So these are the steps. So first it will go, pod will try to scale, because there are only 3 nodes earlier available. Now pods goes into scaling state where HP threshold is crossed. Now it will try to go beyond that threshold, and then again HPA will take a decision to spin up one more pod, and then it will send that message to the Kubernetes that, hey, I want one more node, because I am not able to schedule that pod. In a similar fashion, at the same time, node autoscaler will inform that to the autoscaling group, and pod will goes into a pending state due to insufficient resource which are there in your node groups. Now, as soon as nodes autoscaler will get that information, autoscaler that will that give that information, it will give it to the autoscaling group, and it will try to spin up a new instance. New instance will get provisioned, and as soon as new instance will get provisioned, the pending pod will get scheduled on the new node. So you can see the left hand side corner diagram that now my pods are now in the ready state. This is how like node autoscaling works. So this is very simple, basic. This is the same way, like if you are coming up with the autoscaling as well. So in case of EC2, the only stuff is like Kubernetes autoscaler will not be there, but the same process, like as soon as load increases, one more node will get one more EC2 instance will get added, and that's how like traffic will get distributed all over our autoscaling group. Next. Regarding now Karpenter, now you have a brief idea about like how autoscaling work with cluster autoscaler. Now let's compare that, or let's think in a different way, like how Karpenter works. So Karpenter is basically deployed inside your Kubernetes cluster, and it will try to see what is happening in your cluster. So here in this diagram, you can see one by one. So Karpenter resides in your clusters. It will check for the pending pod as well as unscheduled pod in the cluster. As soon as it gets an information that like existing cluster is full, Karpenter will try to spin up a new instance, and that will accommodate your pending pods in the cluster. So you guys might have a question that like, hey, this is the same thing what cluster autoscaling is doing, but let me give a brief idea about the Karpenter in this diagram. Like if you guys are using GK, you might have heard about the autopilot, or most of some of you are using already using the autopilot. GK autopilot works in a similar fashion of Karpenter, same as like dynamic node provisioning. It's basically reads your files and it provision the new node in your cluster. The same fashion Karpenter works, but Karpenter is an open source tool. It is not associated same as like autopilot. Note that like currently Karpenter is like only works with the AWS, but in the future it might support the other cloud provider as well. So as soon as like what you can see the difference, there is no dynamic provisioning available in the cluster autoscaler, whereas in Karpenter, if you can see, Karpenter first observe your pod specification file of unscheduled pod, calculate the aggregate the resources and request, send that request to the underlying compute services, with the capacity needed to run those pods. So for example, I have one pod which is in the pending or unscheduled state, which is required 1 CPU and 1 GB of RAM. So according to that, whatever configuration I have given to the Karpenter, it will spin up the new instances for you. So this is the how it provision the dynamic instances. It could be, for example, T2 nano or T2 micro, it will get provision. And in case of like classic cluster autoscaler, if you are trying to spin up a new instance, so if your node group is like T2 large or some other family like M1 large, then it will spin up by default it will spin up a M1 large instance in the cluster. So this is how like Karpenter helps in provisioning the dynamic provisioning of the nodes. So underneath the hood, like Karpenter defines the custom resources and called as provisioner, and we'll see the what is provisioner and how you can define that. And you can give the same as like you can compare it with the launch template. So launch template, we give the size of the instances, what are the configuration that we need to give. All this configuration will give it to the provisioner, and provisioner will provision your node. Again, apart from that, like we are also going to see like how Karpenter is deprovisioning of your node. So same as like auto scaling, so load goes down, if you can call it as like in cluster auto scaling, and auto scaling group will deprovisioning the node. Same in a similar fashion Karpenter works, and Karpenter monitors your deprovisioning of the nodes. And if it is like traffic goes down or your HPS come down, as soon as it's there are some flags like TTL expiries, and based on that, whatever configuration you have given to Karpenter, it will scale down your node. And either of these two events triggers the finalization, like which cordons the nodes and drain the pod and terminate underlying compute resources and delete the object. This deprovisioning feature can also be used to keep the nodes up to date with your latest AMI as well. So AMI features that also you can give it to you. It's not depend on like I have to use Ubuntu or Bottle Rocket or some custom AMIs. That is also like you can use in a multiple ways. So I hope like this is an overview of auto scaling of Karpenter, how it works. Then now we'll go to the configuration part. So you can think of like, hey, this is something I feel it complex, but it's not. Just simple 3 steps that you need to do, like pull the Helm chart, create a provisioner and AWS template, and once that is done, you deploy the Helm chart, you deploy the provisioner and node template. That's it. Your Karpenter is now working in your cluster. So these steps are again documented in the Karpenter document. Again, if you are currently using cluster auto scaling, cluster auto scaler for the auto scaling, there is another in the same document. You can see how you can migrate it from the cluster auto scaling with the Karpenter one. And then once you deployed the app, you can check like scaling up and scaling down the deployment, how Karpenter works. Next, 1 second. So yeah, how it works. Then again, as I said, like it watches for the pod. That Kubernetes schedule has marked as unscheduling. Then it evaluates the scheduling constraint based on because it's again deployed in the cluster. It will go for the resource and request. Again, for specific deployment, if you mention that node selector, affinity, 10 tolerant, and all those things, this will Karpenter CRDs will read first, and according to that, it will provision on a node. So depend on that. For example, my particular deployment want to scale, and that particular deployment want a large CPU and memory type of node. So Karpenter will provision only that type of node in your cluster, and those pods will get scheduled on those nodes. And a similar fashion, like again, it's read as I said, it tried to deprovision as well. So if nodes is not required, then it will remove from the cluster. Next. Yeah, so this is the node provisioner template. So you can find it like this may be a human readable, not much complex. So in this template, you can consider like these are the requirement I have given. Like in the requirements, I clearly specify I want C or M or R type of family of instance. This is like M1 or M2 or M3 or C1 C2 or R1 R2 type of instance. Then I have given a CPU. So this level of granularity I can give it to the cluster, that this type of, and within this range only I want a node that should get provisioned. So depend on your requirement, you can might specify that only M series or M1 series, and within that limit as well, I don't want to go for the higher instances, then you can specify like 4 or 8, or you can only specify 8 CPU machine should get spinned up. Then these type of so this type of like again configuration I will give it to you. Can you go back? Yeah, so you can see in the zone as well. So I can spin up a particular nodes in a particular zone that also have the access to it. Then you can go to the last line. You can see that I have mentioned that spot and on demand. So I can spin up a spot and on demand both type of instance. I can provision this template for the multiple provisioner, so that for example I want to spin up for the spot instance, I can create a provisioner for the spot. I want to spin up for the on demand, that is also possible. If you have reserve instances, that also you can specify here. And as you know, like in deployments you given a limits, so that I have given a limit that cluster capacity should not get over like 1000 CPU and 1000 GB of RAM. And down that, like as I said earlier, like if you want to like have the
Apurva, you have 5 minutes left.
Yeah, okay, I'll complete that. And expiry, that will expire, and that will finish if anyone wants to deprovision the nodes. And the last line will be the wait. So it's again same. So if I given a 10, for example, if I given a 10, it range between 0 to 100, and if I given a 10, then and if I mention the values, for example, for the spot instance, then first it will check for the spot instance is not available. And if I given the wait to the 5 to the on demand, then on demand will get spinned up. So you have know how to worry about like if spot is not available, then how my provision cluster will get scaled up. Next. Again the AWS node, this is again the whatever you are giving the specification of EC2 instance, the same thing you have to give it to here. So for example 4 GB of volume type, and what type of storage that I need to give for the EBS volume, that you can give it. And that's all. Like these are the two things that you need to deploy, and cluster will get spinned up. So this is the sample application I have deployed. So you can consider for the left hand side you have node affinity configuration, and in the right side you have node selector. So depend on that, so whatever nodes that are labeled with for example node provisioner as Karpenter, so this second pod will get spinned up on those nodes which are marked as node provisioner as Karpenter. So whereas left hand side I have mentioned as like first it will go for the spot instance and not in the on demand, and if that spot instance is not available, then it will go for the another expression as on demand. So you can consider that if my AWS is try to search a spot instance which I mentioned in the provisioner, and if it is not available, then that pod will get scheduled on the on demand. Next. So again, like you can consider like you can compare Karpenter with the cluster auto scaling. So Karpenter is cloud native scaling mechanism. You have no need to pre-provision the node groups, that you have to define it in the cluster auto scaling with node auto scaler. Then it's a faster scheduling because Karpenter resides in your cluster and it takes a decision and provision a node. Cost optimize, that you can provision because Karpenter again reading your request and limit, and it also takes you to the spot on demand or reserve instances. And yeah, and depend on that, it will be very helpful for the cost. Now, next thing, what you can think of like Karpenter with the cluster autoscaler. This might be a complex idea, but I just want to provision you. So you guys might thinking like you told the story regarding cluster autoscaling and Karpenter, and now you are coming down to the cluster autoscaling with again Karpenter. Why? So you might thinking why we need to do that, or why we can think of this use case. This is just not for the everyone, but think in a different perspective where I want HA for my auto scaling, where sometimes fails cluster autoscaler, or might be there are nodes are under pressure and my Karpenter deployments are failing, and then how in that scenario how my cluster autoscaling will work. So if Karpenter deployment is not working, then if you have the cluster autoscaling in place, that will help you to provision a new cluster. Again, this scenario will help you in the cost optimization. Maybe you can use a cluster autoscaling to have a minimum 1 to 3 replicas for your node, and let Karpenter takes care of the further deployment or further scaling. Because again, cluster autoscaling have the limit, because again, if you are using autoscaling, you have min, max, and desire. And in Karpenter, in the template, as you see, there is no min, max, and desired number of replicas, so it scales up to n number of nodes in the cluster. And now come to the advantages of Karpenter. So first of all, like optimal resource utilization. So no nodes will get like I have 10 CPUs and 100 GB of RAM, and pod will get spinned up with 1 CPU and 1 GB of RAM. That will not be the case for the Karpenter. Customized scheduling configuration, as you see, like node affinity, anti-affinity, and everything that you can see. Can you just go back? Sorry. Yeah, cost saving we already saw. Then again, the fine grained control over the downscaling as well. So you can mention when to downscale my cluster, not to take a hurry decision or not to take a late decision. And it's very easy to integrate with the AWS. And you already saw like it's having built-in spot capabilities to spin up a spot instance. These are the references. You can go through it. Even easy to spot workshop having the Karpenter workshop, so you can play around it in the workshop, and then you can go for it. And next, thanks everyone to listening me. If you have any questions, please do reach out to me, or you can post it in the comments.
Hey, thanks, Apurva.
Any questions?
We have some question, Apurva.
Okay.
We have one question. Scaling, scale out, scale up.
He's asking a scaling, scale out. Can it be done by simultaneously?
Scaling, scale out.
Can it be done by simultaneously?
Scale up, scale
down. Both.
With the help of Karpenter.
Yeah.
So Karpenter basically reads your deployment files. So whatever deployment files that you have, it will try to read the resource and request limits which are mentioned in your deployment file, and according to that, it will provision an instance. So if it is HPI mentioned, and if you want to schedule a new pod, so it will spin up a new node, and that pod will get scheduled on those nodes. And as soon as like if you want to deprovision it, you can see it on the configuration side. In the provisioner, you can mention in how many times you need to expire that node. So if traffic goes down, or if again scaling comes down, it will deprovision that node immediately. Not like a cluster auto scaling. If you work with the cluster auto scaling, then you can see nodes will remains for longer time, so that will cost you.
Okay, thank you. I mean, a small announcement. We do understand there are a lot of technical issues here and there. This is quite happen in live conferences and all. I mean, the pizzas are here. We'll have one last session before we go for pizzas and do networking and the stuff. So, Mohammed.
Thanks, Apurva. I'll
Yeah.
start moving from the page. Yeah, keep yourself muted. Okay.
Can I share like your windows also?
Yeah, okay.
Yeah. Right.
You'll type
Yes. For the
demo also. Okay. This mic is working.
Just
No, I guess.
Okay, anyway, keep
Caller
it like
might
this.
say now.
Right.
I think using callers like
It was here.
Hello. Hello. Hello.
Can you hear me?
it is on.
Hello.
So hi everyone. It's almost lunchtime and this is the last session today. So I'll try to keep it interesting.
No. You need to hold it.
What is Hello. Hello. Could you turn this slide on the way? Hello. I'll just keep Hello. Audible? Hello. Oh, it must be very close.
Yeah.
ಇಲ್ಲ ಟೈಪ್ ಮಾಡಬೇಕು
ಹೊಂದಿರೋದು
Okay, I'll hold it, no problem.
keep it here.
Hello.
Yeah, that also need to keep it close.
That is okay.
Hello. Hello.
Yeah.
Meanwhile, just keep it now. Yeah. While doing the demo. Right?
Yeah, you need to keep it very close.
Hello, hello. Is it audible now? Okay, fine. Hi everyone. I know it's almost lunchtime and it's the last session of the day, so I will try to keep it. So yeah, I'm going to talk about a plugin that I've been working on to manage Kubernetes resources from home. So let's get the boring stuff. I'm a software engineer. I work at Red Hat. I work on OpenShift, which is a productized offering of Kubernetes provided by Red Hat. And in case it wasn't clearly obvious, I like using Vim a lot. Like I use it for everything. I use it to edit text. I use it to watch videos. I even use it to order pizza. So you might think that's a joke, but there's a plugin that makes you order pizza inside Vim.
Bit louder.
Oh yeah. Okay.
Can you try?
I have to. Hello, is this better? Hello, hello. Better? No? Okay. Oh, someone said no. Oh, okay, okay. Yeah.
Can you guys come little bit, my friend?
I'm really sorry for having to get up. Okay. Okay, so I'll keep going. So, like I said, I like using Vim a lot. And one thing that I really like about Vim is that there is no upper limit to the amount of skills that you can do. Like, for example, you can learn as much as you want about Vim, but there is no point that you will ever reach where you can say that I know all of it. I know so many people who use Vim. I met them online, I met them in person, and I haven't met a single person out of them who can tell me that they know everything about it. So some people think this is a negative aspect, but I think it's really good because it shows that the more time you spend on learning Vim, the more better you get. And there is no upper limit. Like you can keep spending effort and time on it and keep getting better. You get even more rewarding. So it's essentially like reducing friction in your workflow by becoming more efficient. So that brings me to my next point, reducing friction when it comes to working with Kubernetes. So I've been trying to increase my workflow efficiency when I have to use Kubernetes, and so it led me down this path creating a plugin for me. So the first thing I realized when I looked at my workflow with Kubernetes is that I use a lot of UCTF. I mean, it's obvious it's a central standard way of using of interacting with the Kubernetes cluster. And I looked deeper into this, and then I realized that every time I use the UCTF command, it involves me doing some kind of third operation on the cluster. Create, read, update, delete, whether it be deployment or updating or deleting pods, managing sources, and so on. And since it is third operation, it also means that I'm editing a lot of text, editing manifest files, creating YAMLs, and all that. So when I wanted to design, I made a list of all the things that are important to my work. So something like a multi-pane workflow. So pane, if you're not familiar with the technology, it's a thing in Vim that used to represent multiple windows open at the same time. So you will have multiple files open in a single Vim instance. Look at all of them at the same time. That is kind of important to me because I like using a lot of files, like having a lot of files open. And the second point is asynchronous nature. So to show you what I mean, I'll quickly go through a demonstration for this. I'll have to put the mic down, but I'll bend down to talk. So I'm going to open Vim now. It's fine.
Can you use chair? Better.
Yeah.
You can keep.
No.
You can keep here.
Ah.
Like this.
No, you stand. I don't.
Okay. Yeah.
Okay. So this is what Vim looks like. What the way you run a custom shell command inside Vim is by typing colon and then exclamation, and then you write the command that you want to use. So for example, if I wanted to run ls, I just have to type ls and press enter. What happens when I do this is the command to execute the command Vim has to temporarily close itself. Then I'm going back to the shell here. Once the command has been executed, it shows me the prompt, and when I press enter, I'm going back into Vim now. So this is what I mean by asynchronous workflow, is that I don't want to have to close Vim and wait for the command to execute, especially when, for example, if you're running a long-running kubectl command, you don't want this to disrupt your work. You want the shell command to run in the background and not block the Vim editor for you. So yeah, this is the architecture of the plugin. I initially thought of directly interfacing with the Kube API, but then I realized that I have to implement all of wanted things like authentication and API discovery, and I didn't want to do all of that. So until I find a better solution, what I'm going to do is back over the kubectl command and use Vim's asynchronous API to kind of offload all of this operations to kubectl. And note that I'm saying async API for Vim, but Vim also has think of it as a sibling text editor called NeoVim, which is slightly different than Vim, but the async API is almost similar. So this plugin works on both Vim and NeoVim. Okay, moving on to demo. Before I move on to demonstration, I'll just quickly show you how you can install this. So this is the repository of the plugin. If you've ever installed a Vim plugin before, then you know exactly what you do. You have to follow the instructions for the plugin manager that you use, or you can use any package management solution, because this follows the standard plugin architecture, which is okay. But if you have never installed a Vim plugin before, all you have to do is clone this repository into the .vim directory of your machine, and it should, when you open Vim next time, it should be up. So yeah, moving on to the demo. The first command that I want to show you is the kget. This I consider the entry point of this plugin. It's one of the most used commands of this plugin. I can give you a demo. So I'm going to open Vim, and when I type kget without any parameters, what this does is it tries to fetch the list of all pods that are running in the cluster that I'm connected. So right now I'm actually running a kind, which is Kubernetes and Docker. It's a local setup that's running a cluster in my local machine. And as you can see, this gives me a bunch of information. It gives me the namespace, the resource, which is pods for now. And then it gives me a command to show me the help documentation of this plugin. And it's not just limited to pod, but it can show me pretty much any resource, whether it's a CRD installed by Apurva, default Kubernetes resource. It's going to show me any resource that's available in the cluster. For example, if I wanted to see the list of deployments in my cluster, I just have to type kget and then type deployments. Yeah, so as you can see, I have 2 deployments in this cluster right now. And another thing that I can do with this is it's not just a static list of objects that you get when you run the kubectl command, but it's actually in sync with the cluster. Like for example, to demonstrate the synchronous nature of this, I will show you another command, which is just K. So this is kind of a synchronous wrapper to the kubectl command. What this does is it lets you run any arbitrary kubectl command, but it doesn't block the Vim editor or doesn't close the editor for the command. It runs entirely in the background and it's going to notify me when it's run. For example, if I had to create a deployment, the command to do that is kubectl create. So instead of kubectl, I'm just going to use K, and then I'll type the whole command. So I'm going to call the deployment as, and then the image is just going to be Nginx. So when I run this, you'll see that it doesn't block it out, and the list is actually now updated. I now have a third deployment here, and then there's also a new pod that just showed up because of it. So this is fully asynchronous, and it's always kept updated with the cluster. So you don't have to worry about data going stale. And then another really neat thing you can do about this is delete resources from here. So normally to delete a line in Vim, you have to press delete once, and that deletes the line. But in this plugin, if you delete a line, it's going to go ahead and delete the resource that that line is having. For example, if I wanted to delete the deployment that I just created, I just have to put my cursor on it and delete it. It's going to ask me for confirmation, and once it gets deleted, you can see that it's removed and the pod that's created. So moving on, another very important thing that you can do in this view is edit resources directly. Like for example, I have a pod here, and I wanted to check the YAML of this pod, the manifest of this resource. Simply have to press I twice, and it opens up the YAML of. And I can do all sorts of changes here. And when I save this file, it's going to update or apply this change to the cluster. So I can do that as well. So moving on to the next command, this was the kget, and k is also what I just covered right now. Then kedit is just another wrapper to what I just demonstrated about editing YAML. You can do the same thing with k. You just have to type k-edit and then the resource name that you want to put. If I don't know the resource name, I can also just press tab, and it's going to show me a list of all the resources. So you have bindings, component status, everything that's available in the cluster. I can now access. And I can then write the name of the resource that I want to edit. And when I do that, it should open the YAML. We just did that, so I can skip it for now. And the next is just a little helpful utility that lets you switch a namespace or get the arguments. So if I run the kns command without any arguments, you can see that it shows me the namespace that I'm currently in. And if I wanted to switch to a different one, I just have to type kns and then the name of the namespace. And if I again press tab here, it's going to show me a list of all the namespaces that are in this cluster. These are the default ones that so I just click it now. You can change the namespace. So the next command that I want to talk about, this is probably what I can consider the most useful command in this plugin. It's so useful that I use it every day and now. So what this does is it's essentially an improved version of kubectl and apply. So the way you apply resource management to Kubernetes is you either pipe the output of the YAML into the kubectl apply command, or you can save this to a file and then use the -f flag to apply a file this is very slow and somewhat difficult to use. So what this does is, for example, if I have a YAML file, say this map, and what I want to do is I want to apply this YAML to the cluster. I can either just copy paste this YAML into Vim and then run kapply, or if I have it saved as a file, I simply have to open this file in Vim and then run kapply. If I run kapply without any arguments, it just applies this file. You can see it says it's created, and I can look at the resource by opening kget and then type cm, just short for config map, and close the deployments view. And you can see that my config map is now available. And I can also just to show you that this doesn't actually operate with files, it operates with just the text that is visible here. I can simply edit this config map, change the name to, let's say, my, and then note that I'm not going to save this file. It's just I'm just changing it but not saving it. So if I apply it now, it should create the new resource with my data too. And note that I still haven't saved the file, so it's just reading text directly. It doesn't have anything to do with file, so it's a much faster approach. Finally, one very good thing that this can do is apply partial YAML. So let's say you have, let's say you have lots of resources. Sorry, one second. So let's say you have a YAML file which has lots of resources, like this one that has a config map, a bunch of different things in a single YAML, which is common for very large projects. And let's say you wanted to apply only one specific object in this YAML. Let's say I wanted to apply only this pod instead of the whole YAML. So normally with kubectl apply, you have to either copy paste this YAML into a different terminal and then run it, or you have to save it into a new file. But with this, all I have to do is select the resource that I want to apply and hit kapply. This time, it's only going to apply the resources that I have selected. So it's only going to apply the resources that I have selected. So in this case, I just created the pod, as you can see, and it has not created anything else. So if I look at kget for now, as you can see, the pod has been created. But rest of the resources are in the same YAML. So it's very helpful if you're dealing with lots. That was the last command. For now, this is all that the plugin can do. This is the GitHub repository of the plugin. I have a bunch of ideas that I am planning to implement for this. So if you would like, feel free to check this out. Try to run it. If you get some bugs, feel free to let me know. I would also like to know if you have any other ideas for contribution or any future requests that you would have. Feel free to create issues or pull requests. I'm always happy to get in touch with you. And also, this is my website. You have a bunch of other things here. I like using Mastodon, so if you're looking for someone to follow, you can follow me on Mastodon. I think that's all I have. Thank you for listening.
Can you give that? Yeah.
So in that case, let's say if I delete a secret and the pod thing is not
You're asking whether the pod will be restarted. Yeah,